Okay, so I'm so sorry about it. I just got disconnected, and now let us restart the session. I was like, what what happened, right? So yes, I don't know, guys. Something got disconnected, and the live went. But now I am back, right? I literally, my mood was whole spoiled that, oh my God, such interesting lecture was going on, and now we'll have to do that again, right? So let us start that again. Now, guys, where we were at this chemical bonding, right? I was telling you that we had VBT, Vesper, and hybridization. Then we will do MOT, dipole moment, and bond angle. The big chunk of this thing we have already done, that is VBT, Vesper, and hybridization. Firstly, I taught you with my own handwritten notes, that is overlapping. What is VBT? What is hybridization? What is this different hybridization based on the lone pair and the bond pair, right? Okay, I've also shown you this with the help of 3D models like this, right? Now, those students who have not watched that video, guys, you will see the part 1 of that, right? Who are watching the recording, see the part 1 of that video, of this video. You will see day 1 in organic chemistry, chemical bonding plus coordination, part 1. So that is around 1 hour session. You can just watch that and then join this, right? Now let us see this, where we were at this point, right? We were at this question. The question was regarding S2O3 2 negative, SO4 2 negative, SO3 2 negative, S2O7 2 negative. Now, if you talk about this thing here, right, this is the good time, ma'am. Yes. So now let us talk about this thing here. If you talk about SO3, right, guys, how to understand the structure here, I'll tell you. First thing is, they are asking you, let us solve for SO3 2 negative. Now just draw the simple structure firstly. Always and always remember, when oxygen is forming one bond, in that case it is having that negative here. When oxygen is forming two bonds, it is neutral. When oxygen is forming three bond, it is positive here. So okay, so now O negative means it is forming one bond. One oxygen is not having anything, that means it is forming double bond here, right? Now we know that sulfur belongs to oxygen family, that means it should have 6 valence electrons, right? Now these 6 valence electrons are not completely consumed. As you can see here, this is 1 electron, 1 electron, 1 electron, 1 electron. So 4 electrons are being consumed here, and you are still left with the 2 electrons, right? That means these 2 electrons are your lone pair. That means here you are going to have one lone pair as well, and total you can see it is having 3 sigma and 1 lone pair. That means total 4 is the factor here. That is why we can say that it is having tetrahedral geometry, but the shape is going to be pyramidal. Can you tell me why the shape is going to be pyramidal? Because in tetrahedral geometry, as I have shown you here, that in tetrahedral geometry like this, okay, so in tetrahedral geometry, if you have something like this in the tetrahedral geometry, what was the problem? Yeah, I don't know. I think maybe some network issue was there. That's why this happened, right? Now, as you can see in tetrahedral geometry, when you pick out one bond pair from there, right, then you will have a pyramidal geometry, right? You will have a pyramidal geometry. Basically, that is why this is going to be pyramidal in nature, right? So that is why this is the structure that is pyramidal. Rest of these will have tetrahedral structure. Let us see how. So as you can see, if you talk about SO3, let's say you talk about SO4 2 negative. That means you have 2 oxygens which is having negative and 2 oxygen which is having double bond. Only then you can have SO4 negative. Now this you can see 4 sigma bonds here. That means this is also existing in tetrahedral geometry like this, right? Like this. This is the tetrahedral geometry of SO4 2 negative. So it is not pyramidal. If you talk about S2O3 2 negative. Now here again draw this sulfur. You have 2 oxygens which are negative, right? 1 oxygen which is neutral, and you are left with one more sulfur. Now this sulfur will be bonded with, yes, this sulfur will be bonded with, yes, bacha, definitely I'll take organic also for you, don't worry, right? So now you are left with these 4 electrons, 1, 2, 3, 4, right? Now we know that sulfur need to have 6 electrons here, that is why one lone pair will be present here. But the formula is S2O3. That means these 2 electrons are going to form one double bond with one more sulfur. And again, it is having 4 sigma bonds. That is why it is going to have tetrahedral shape like this. This is the tetrahedral shape. So also the tetrahedral shape. Now, let us talk about S2O72 negative. In S2O72 negative, what we are going to do? You have O7, right? So, one sulfur, O72 negative. That means only 2 oxygen are going to be negative. If you have O negative here, other oxygens are going to have double bond, right? Other oxygens are going to have double bond. Now you have S2O6, S2O62 negative. If I join this by a oxygen as a bridging bond, as a bridging atom, it will become S2O72 negative. So this is the structure of S2O72 negative. So answer is going to be, this is the only pyramidal. Rest of them are tetrahedral. Next question on your screen, what we have, number of molecules. Okay, next question on your screen is number of molecules. Number of molecules, ma'am, is there any lone pair in SO42 negative? No. On sulfur, there is no lone pair on SO42 negative, right? Okay. Now, number of molecules ions for the following in which central atom is involved in sp3 hybridization, right? So let us see the structures you can easily draw in the same way, right? So what will happen here, I'll just also show you the structures, because we need to do things in a fast track manner, fast forward manner, so that we can also complete 2 chapters today. So now as you can see here, this nitrogen, it is having 1 sigma and 1 sigma. So that is why it is having 3 sigma. So answer will be sp2 hybridization. Here it is having 1 sigma, 1 sigma, 1 sigma. Again it is 3 sigma. So sp2 hybridization. Here it is having 1 sigma and 2 lone pairs, right? So it is sp3 hybridization. How you will get to know about the lone pairs? Guys, see, boron is having 3 valence electron and it is forming 3 bonds here. So that is why there is no lone pair here. Nitrogen is having 5 electrons in the valence shell, right? 2 electrons are here, 2 electrons, 1 electron here, total 3. And this is a coordinate bond. So one lone pair is getting donated to this oxygen, right? So that is the coordinate bond. That is why we are saying that it is having 3 sigma bonds. Coordinate bond is also taken as sigma bond only, right? If you talk about this chlorine is having 7 electrons in the outermost shell. If you talk about the 7 electrons in the outermost shell, can we say that these 7 electrons, now it is basically ClO2 negative. That means one chlorine will be negative, one chlorine will be neutral. So that means one is double bond, one is single bond. Now, after this, we know that after using 3 electrons, this is the first electron, second electron and third electron. After using 3 electrons, you are left with 4 electrons. That means 2 lone pairs here. That is why we have drawn 2 lone pairs here, right? That is why we have drawn 2 lone pairs here. What about the last one? This is ClO3, right? How you will write for ClO3? They have given this thing to you. Chlorine is having 7 electrons. If oxygen is neutral, there is no charge. That means oxygen is having double bond with the chlorine. Oxygen always form double bond when it is in the neutral state, right? Now 1, 2, 3, 4, 5, 6. That means 6 electrons are being consumed. You are only left with 1 electron in the end. This is a odd electron. Very, very important compound. This is a odd electron, as you can see. So answer is here the hybridization. Why it is sp3? It is 1 sigma, 2 sigma, 3 sigma, and this odd electron is also it also takes part in the hybridization. So answer is going to be sp3 hybridized. Is that clear to everyone here? Is that clear? Right? Okay. Is that clear or not, guys? Is that clear or not? Next is why I am teaching you these structures, right? Because from here only you will see your questions in JEE mains, right? Next is number of compounds with one lone pair of electrons on central atom amongst the following is, right? So they are telling you number of compounds with one lone pair of electrons on the central atom. There should only be one lone pair here, right? So as you can see here on xenon is having 8 electrons. It belongs to noble gas. 4 electrons, 8 electrons, 4 are already consumed. That means you are left with 4 electrons. That means 2 lone pairs. So here the answer is 2 lone pair. What about BRF5? Bromine belongs to halogen. That means 7 electrons. Okay. Bromine belongs to halogen. That means 7 electrons it is having. So out of these 7 electrons, you will see that 5 are already consumed. BRF5. 5 are already consumed. So you are left with 2 electrons here. So that means 2 electrons means 1 lone pair. So this is having 1 lone pair. What about NH3? Now you have 5 electrons. Nitrogen. Nitrogen belongs to group number 15. That means 5 electrons. 3 are already busy in making bond pair. So you have 2 electrons. 2 electron means 1 lone pair. So it is also having 1 lone pair. What about ClF3? Everybody in the chat box, what about ClF3? ClF3, chlorine is having 7 electrons. 7 electrons, right? Now, from these 7 electrons, as you can see, 3 bonds it is forming. So it is left with 2 electrons. That means it is having 2 bond pairs, right? 2 lone pairs. What about SF4? SF4. Sulfur belongs to oxygen family, right? Oxygen family means group number 16. So here we can say that sulfur is having how many electrons? Group number 16 means it is having total 6 electrons. Out of that it is making 4 bonds, right? So you are left with 2 electrons. 2 electrons means 1 lone pair, right? So here the answer will be 1. What about H2? What about H2? Here the central metal atom is oxygen. Oxygen having 6 electrons belonging to group number 16. 6 electrons as the valence electrons, right? So how many bond it is forming? 2 bond it is forming, right? Now that means 4 electrons. That means 2 lone pairs. What about O3? Very, very important molecule, that is O3. O3, it will exist like this, okay? Here it will exist as a resonating structure, right? So what you will see, one oxygen will be, wait a minute, one oxygen will be positive, right? Okay, one will be negative. O3, right? Wait a minute, I'm drawing O4. O3, 1, 2, 3, right? So here you will have one oxygen will be double bond, right? So here it will be negative and here this is, wait a minute, here it will be positive because here the oxygen is forming 3 bonds. Whenever it is forming 3 bonds, it is having positive charge. Whenever it is forming 2 bonds, it is having negative charge. So this is the structure of oxygen, right? Now as you can see here, how many lone pairs in the central metal atom? How many lone pairs? It is having 6 electrons, right? Out of those 6 electrons, how many electrons are already consumed here? How many electrons? 1, 2, 3. 3 electrons are already consumed. You are left with 3 electrons here. That is why you will have one lone pair here, right? So answer will be 1. Okay, answer will be 1. Okay, so basically it is going to donate one lone pair to this side, right? It is going to donate one lone pair to this side. So basically what is going to happen, out of this 6, 4 electrons will be consumed because 2 electrons are involved in this double bond and 2 electrons here. They are donating the electron. They are giving the electron to this electron deficient oxygen, right? So that is why 4 electrons are involved. 2 electrons you are left with. That is why 1 is for O3. So answer is how many number of compounds which have one lone pair of electron on the central metal atom. So that is 1, 2, 3, 4. So answer is 4 is the correct answer. Okay. Yes, 4 is the correct answer. Next guys, everybody try to answer this question. Your list one is BRF3. Then you have to tell me what is the shape of this molecule. So very simple. We have already done this. Right? BRF3, BRF5, sorry. So it has 7 electrons, 5 electrons are consumed. You have 2 electrons. That means 1 lone pair plus 5 bond pair. 1 lone pair plus 5 bond pair means it is going to have octahedral geometry, and square pyramidal is going to be the shape. So A is going to be 4. So you can see the answer as D is the correct answer. Okay, directly you can see that D is the correct answer. Okay, directly you can see that D is the correct answer. Okay, why you are writing it as B? It has 7 electrons, 5 electrons are consumed. You have 2 electrons you are left with. So 5 bond pair plus 1 lone pair. That means it is going to be square pyramidal. Okay, it is going to be D. Right? Okay, what about B? B, so we know that it is water. It is bent shape. Right? It is bent shape. So B is third. Then you have ClF3. What about this ClF3? Again, chlorine is having 7 electrons. 3 electrons are consumed. You are left with how many electrons? 3. You are left with 4 electrons, right? So that means 2 lone pairs you are making here. 2 lone pair plus you have 3 bond pair. Geometry is going to be trigonal bipyramidal. When you attach 2 lone pairs on it, it is going to be a T shape. So answer is going to be T shape. So C is your first. What about D? SF4. What about SF4? Sulfur belongs to which family? Guys, sulfur belongs to which family? Sulfur belongs to which family? Hanji, everybody. Yes. Orbital or hybridization, ma'am. Any compound odd electron also participate? Yes. Yes, Sumesh. Yes, Sumesh. Here we are taking odd electron participating. Right? Okay. Odd electron is participating there. Right? Now, let us talk about this S sulfur. Sulfur is having 6 electrons here. Right? Now, 6 electrons, 4 electrons are already consumed. You are left with 2 electrons. 2 electrons means 1 lone pair. 4 electrons were involved in bond pair means 4 bond pairs. Total it is 5. So it is going to be trigonal bipyramidal is going to be the geometry. When you replace it with 1 lone pair, for example, here you have the trigonal bipyramidal geometry. And when you replace that one with the lone pair, right, here what you will have? What is this structure? This is called seesaw structure. Right? So answer this is going to be 2, that is seesaw. Now everybody, let me know in the comment section if you are able to solve the questions. They will give you some compound. You have to decide how many lone pairs, how many bond pairs, so you can directly see, right? Sigma bonds you have to calculate. How many lone pairs you have to see. After that you will tell the shape and the geometry. How many of you can easily answer this? Let me know in the comment section. Let me know in the comment section if there is any problem, because next topic is going to be molecular orbital theory. We are going to start with the molecular orbital theory. Yes, I want to see that in the comment section. How many students are able to answer these, have got the confidence to answer these questions easily, right? If yes, then green hearts in the chat box. If you are able to answer this, I'll like that will be, or you can just thumbs up in the comment section. That will help me to understand whether you are able to understand this or not. Okay? Yes? Okay. Why late, ma'am? Arey, I am not late. I was here at 7 p.m. only. There is part 1 of this session. I got disconnected. That's why I have to make the stream again and now again join you guys. Right? So those students who have not watched the part 1 of this, kindly watch. It is a 1-hour video and very, very important. Right? Okay. Yes. Now, let us do molecular orbital theory. Now, from molecular orbital theory, how the questions are asked, very simple. Right? Molecular orbital theory is basically when the atomic orbitals, they are saying that the wave function of atomic orbitals, they are combining to form molecular orbitals, right? Molecular orbitals. You can say that When they are constructively combining, they are forming bonding molecular orbital. When they are destructively combining, right? That means when the wave function is getting subtracted, they are forming anti-bonding molecular orbital. This is represented by no star. There is no star over here. This is represented by a star on it, right? For example, I want to say that there is 1s bonding orbital, there is 1s anti-bonding. For bonding, I will not write any star, but for anti-bonding, I will write one steric here, right? That will represent the anti-bonding orbitals. Now, next thing is that here, whenever we are going to apply this, what will happen? Like we did electronic configuration and structure of atom, it is also going to have its own electronic configuration, right? But this electronic configuration, I'm going to give you a simple thing here. That is, when you have less than or equal to or equal to 14 electron, right, in that molecule, because the questions you will see in your JEE means are based on this concept only, right? More than 14 electrons. These are the two things. Now, when you have less than or equal to 14 electron, that is 2 1 2 1, and here it is 1 2 2 1. That's it. Okay, 2 1 2 1 1 2 2 1. That's it. This is all you need to remember for your question solving. Okay, this is all you need to remember. Okay, shall we start? Shall we start doing the questions now? How we are going to solve the question based on this particular thing? Are you all ready? Are you all ready? Let's do the questions now. Okay. So the first question, as you can see on your screen, is the linear combination of atomic orbitals to form molecular orbitals takes place only when the combining atomic orbitals, they are saying, when the combining atomic orbitals have same energy, have the minimum overlap, have same symmetry about the molecular axis, have different symmetry about the molecular axis. So when they are combining, when these atomic orbitals are combining, what is the correct thing? They should have the same energy. Yes. Have the minimum overlap? No. Right? Have the same symmetry about the molecular axis? Yes. They should have the same symmetry and same energy, because 1s will combine with 1s, 2s will combine with 2s, 3s will combine with 3s only. So same energy and same molecular symmetry it should have. Have different symmetry? No. So answer they are asking you is which is correct, right? Okay, choose the appropriate options given below. So A and B is the appropriate, A and C is the appropriate option. So B is going to be the correct answer here, right? Next we have when they are saying when psi A and psi B, the wave functions of atomic orbitals combine, they are saying you are making anti-bonding molecular orbital. I told you just now that for anti-bonding molecular orbitals, the wave function will get subtracted, right? So this will not happen, this will not happen, this will not happen. They will get subtracted. So answer will be B is the correct answer, okay? Now, next is number of molecules having bond order 2 from the following molecules is. Number of molecules having bond order 2 from the following molecules is. You need to tell me number of molecules having bond order 2. Now, ma'am, how to calculate the bond order? Very simple, okay? So, I am going to give you a very simple thing here, right? So, first is C2. Because see, in the exam, right, in JEE means what they give you a lot of questions, right? Okay, so in one question only, they have asked so many questions here, right? So how to do that, right? So firstly, if you talk about C2, in carbon 2, how many electrons you have? In one carbon, you have 6 electrons. In 2 carbon, you will have 12 electrons. 12 electron is less than 14, so it is going to be 2121. I'll tell you what is 2121. 2121 is basically your orbitals here. This is 2 1 2 1. Just make this thing here. and always subtract 8 electrons initially. Why we are subtracting 8 electrons always? Because bacha, if you see the electronic configuration, right, firstly, so you will have sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. So here 8 electrons, so you will always fill, right? If you have more than 8 electrons in total, then why to write this again and again and again? Because when you calculate the bonding order, the bond order, it is anti-bonding electrons, anti-bonding minus bonding electrons divided by 2. So here bonding and anti-bonding will subtract 2 minus 2 is 0. 2 minus 2 is 0. That's why I'm saying just eliminate 8 electrons before only to save your time. Got it? To save your time, eliminate 8 electrons. How many of you understood this thing? That whenever you have more than 8 electrons, just eliminate, just subtract 8 electrons from that. Is that clear to everybody? Guys, on every step you can ask me, because see what will happen when I teach you a whole concept, after 5 minutes you say, ma'am, I'm not able to understand that, right? So at every step I'm asking that if this thing clear to you. Now you have 12 electrons, so answer will be 12 minus 8 will be 4 electrons you are left with. So now you have to fill these 4 electrons in 2 1 2 1, that is firstly degenerate orbital once more. Okay, so I'll teach you one more also. See, when you see the electronic configuration, it is like this: sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Then depending upon whether it is more than 14 electron or less than. If it is more than 14 electron, it will be, sorry, if it is less than 14 electron, it will be basically, this is your pi 2p x is equals to pi 2py, right? Then you will have, these will be equal, right? Then you will have, after this you will have sigma 2pz, right? Then you will have 1 or 2 only, na? This will be pi star 2px equals to pi star 2py. Then this is going to be sigma star 2pz. So this is, I am representing 2 1 2 1. This is what I am representing by 2 1 2 1, right? Okay. This thing we represent by kk star. In kk star, always you will have 8 electrons, right? Always you will have 8 electrons. Now I am telling that a short trick is, instead of writing this again and again, because in the bond order, what you are going to do, you are going to see anti-bonding electrons minus bonding electrons divided by 2. Here 2 subtracted, 2 subtracted. The difference you will observe is on this part. So why not to focus only on this part? Because we are going to solve big questions here. That's why just subtract 12, just subtract 8 from 12, right? From this 12, just subtract this 8, right? That is kk star, right? You will have 4 electrons here. Now you just need to fill these 4 electrons in 2 1 2 1. 2 1 2 1 is for equal or less than 14 electrons. So it is 1 2 3 4, right? So also you can write one thing here. This is your bonding, this is your anti-bonding, this is also anti-bonding. This is sigma 2pz, this is pi 2px, pi 2py. This is sigma 2pz, this is pi 2px, pi 2py, right? Because they have the same energy. This is star, this is star, this is also star. Got it? Got it? So here how many electrons? Guys, everybody in the comment section. 12 minus 8, you have 4 electrons here. So 4 electrons, can I say that 4 electrons means these 4 electrons are existing in only the bonding orbital, right? So here answer is going to be, your bond order is going to be bonding minus anti-bonding. Bonding is 4 electron minus 0 by 2. It is going to be 2 is going to be the order, right? 2 is going to be the order, right? Okay. That was the first thing. Second is O2. Now O2 means in one oxygen you have 8 electrons. In 2 oxygen you will have 16 electrons. So here it is 16 is more than 14, right? Obviously 16 is more than 14. So when you have more than 14, what I told you here? I told you here that more than 14 you have 1 2 2 1, right? So we'll just write it here 1, 2, 2, 1. So answer will be 1, 2, 2, 1. Here what we are going to do, 1, 2, 2, 1. So here this is not the right way for more than electrons. For more than 14 electrons, what you will do? 1, 2, 2, 1. Okay, so I'll just write it again. 1, 2, 2, 1. 1 means they are talking about 2p, sigma 2pz. Here also sigma 2pz. This is anti-bonding, this is bonding. This is pi 2px, pi 2py. Okay, this is pi 2px, pi 2py. This is anti-bonding. Now, again you are going to subtract from these 16, we will subtract the 1s, 2s electron. That means 8 electrons, subtract 8 electrons. So you will have how many electrons? You will be left with 6, 7, 8 electrons only. So now you are going to fill these 8 electrons here. 1, 2, 3, 4, 5, 6, 7, 8. Because degenerate orbitals, first you will singly fill them. That's why I have filled it like this. Why? Because firstly, this is only one orbital. So 1, 2. Here, these are two degenerate. So 1, 2, then 3, 4. Here, 1, 2, 3, 4, 5, 6. Now 7 and 8. We have filled all the electrons. By this, you can also say oxygen is paramagnetic in nature. And the unpaired electrons are in the anti-bonding orbital. Right? So they can also ask you, yes, bacha, this is life. So anti-bonding orbital, they can also ask you that what is the anti-bonding orbital where you have the unpaired electron. So that is in pi 2px star and pi 2py star. Okay, got it everybody? Got it everyone in the chat box? So here the bond order is going to be anti-bonding electron, bonding minus anti-bonding. Bonding is 1, 2, 3, 4, 5, 6. So 6 minus 2 divided by 2, that is 4 by 2, and answer is 2. That's why for oxygen, we have double bond. For C and C also there is double bond, right? Okay. Now, next is what they are asking. Next is they are asking you about lithium, Li2, Ne2. Right, so let's write this about the lithium. Lithium, everybody. Lithium. Anybody, what is the bond order of lithium? Anybody who can tell me what is the bond order of lithium? Anybody in the comment section? For lithium, firstly let us talk about beryllium. Beryllium 2 is hydrogen, helium, lithium, beryllium. Beryllium means 4 electron. That means total it will have 8 electron. 8 electron means it is having 2, 1, 2, 1. That means this kind of situation it is having. Now guys, it is having only 8 electron. Now don't subtract 8 electrons from there. It is having a simple electronic configuration. Sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. So the bond order is going to be, this is going to be, in bonding you have 4, in anti-bonding also you have 4, right? So that is why it is going to be 0. That is why beryllium twice will not exist, because the bond order is going to be 0. Okay, bond order is going to be 0, and the compounds which has bond order as 0, they don't exist. Okay, they will not exist, right? Next is, let's talk about the next is for lithium. Now I can see in the comment section you guys are writing, ma'am, lithium is 3 is the bond order, right? Okay, so let us see for lithium if 3 is the correct answer or not. Lithium twice. Hydrogen, helium, lithium. 3 is the atomic number, ma'am. Okay, beta. 3 is the atomic number, means 2 lithium will have 6 electrons. 6 electron, again it is less than 14. So here we will apply this trick, 2, 1, 2, 1. That means here only this trick will be applied here. But ma'am, it has less electrons. Why we don't even need to do this, ma'am? It is very simple. I said, okay, if you are telling that it must be simple only. So it is 6 electrons, okay? So answer will be sigma 1s2, right? Sigma 1s2, sigma star 1s2, sigma 2s2. Now, bond order is going to be, this is how many bonding electrons? 1, 2, 3, 4. Anti-bonding 2 divided by 2. Here it is going to be 2 by 2. Answer is going to be 1. Answer is going to be 1. Okay. Answer is going to be 1. Okay. Yes. Very good, very good, very good. What the number of molecules having bond order 2? Bond order 2 to bacha, these two are having the bond order 2. Others will not have bond order 2. Firstly, let me tell you, this to will not exist only. We will also see the reason behind that, why it will not exist. Okay, we'll also see the reason. See, in one question, you are doing almost all the examples, right? That is the beauty of questions. When you do the questions along with the concept, right? I can assure you that your full brain will get open and you will have to use your brain, right, to solve the questions. When you're studying only the theory, then it is difficult to solve the question after that if you're not practiced anything, right? So now we have completed these 4. Now we have neon 2. Firstly, so guys, neon twice, neon 2 and helium 2 will not exist only because they are noble gases. Like, so you don't even need to calculate that. But still, curious minds, for those curious minds, okay? So neon 2, we know that 1 neon is 10 electrons, 2 neon is 20 electrons, right? So 20 electrons, that means more than, it is more than 14. So it is going to use 1221, right? So guys, from 20, it is like more than 8 electrons. So just subtract 8 from here. 20 minus 8 is going to be 12. So put these 12 electrons in this case. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Can you see? The whole thing we have covered, right? Whole thing we have filled here, right? So can I say that here bond order is going to be how many bonding electron? 1, 2, 3, 4, 5, 6. How many anti-bonding? 6. Divided by 2, this is 0. That is why Ne2 does not exist, right? Same will be with lithium. Same thing we will, not lithium, same thing we will see with helium, right? Helium is also, it will not exist. It will not pair up with anyone, right? Now, helium 2. Helium means hydrogen, helium 2 electrons, right? So 2 helium means 4 electrons. It is less than this, so it is going to be 2121, right? Now, here, simply you don't even need to use this diagram here. So answer will be sigma 1s2, sigma star 1s2. Can you see what is the bond order? Can you see what is the bond order? Bond order is bonding minus anti-bonding by 2. So answer is going to be 0. Right? Again, it is 0. Guys, tell me, is this thing getting clear in your head? Right? Okay. Are you able to do this? Right? Very good. Now, last is your nitrogen. Right? Last is nitrogen, N2. So for N2, very simple. We have covered everything. We are just left with N2, very important. Right? Nitrogen is having, what is the atomic number of nitrogen? What is the atomic number of nitrogen? 7. So 2 nitrogen means 14 electrons. It is equal to 14. It is equal to 14. So here what you can say that, here we will use which mantra? We will use 2121 because it is equal to 14. Right? So we will use this thing, 2121. Now, from this 14, subtract 8, you will get 4. Not 4, you will get 6. Right? Now, 6 electrons you have to fill here. So, it will be 1, 2, 3, 4, 5, 6. So, the bond order is going to be, everybody, the bond order is going to be, it is going to be 1, 2, 3, 4, 5, 6 minus 0 divided by 2. Answer will be 3. That is why nitrogen is having 3 bonds, right? Okay, that is why nitrogen is having 3 bonds. Got it? Yes. Right? Okay. In exam, though, you will remember this directly. Now, this was though a trick for you, right? Now, I'll tell you directly how to solve this. Okay? With this very simple thing, I'll tell you directly how to solve this. Right? Okay, guys? Okay. Chalo. Now, let us see directly how to solve this. Just remember, this is your bond order. This, though, guys, I told you that like how to properly solve this. But now I am going to give you just one simple trick here, right? Okay. Now, this is, ma'am, why to subtract 8? Beta, we are subtracting 8 because I am not writing the full configuration. 14 electron means you will have 1s also. This is 2p, this is 2p, right? Those 8 electrons will get into sigma 1s, sigma 2s, sigma star 1s, sigma star 2s. Total it will be 8 electrons. That's why I'm subtracting 8 electrons, right? Okay. Now, this is the bond order. This is the bond order. Directly, these are the number of electrons. Number of electrons. Just remember one thing. Just remember one thing. 14 is 3. If you have 14 electrons, then the bond order is 3. 14 electrons, then the bond order is 3. Now, just increase here. 15, this is 16, this is 17, this is 18. This is 13, this is 12, this is 11, this is 10. Right? And increase 0.5, 0.5 here. Okay, 0.5 will be increased. 14 is 3. 0.5, 2.5. It decrease 0.5, it will be 2. Decrease 0.5, it will be 1.5. And decrease 0.5, it will be 1. It will be 1. Okay, it will be 1. Here increase by 0.5, it will be, sorry, here also decrease by 0.5, it will be 2.5. It will be 2. It will be 2. It will be 1.5. It will be 1. So this is a simple trick. Okay. Okay, guys. Okay. So this is a simple trick. By this also, you can directly solve this. Now, we have solved one question by proper method. Now, I am going to solve other questions by simple trick. Okay. So this was the answer, that C2 and O2 have 2 as the bond order. Now let us see this question. Everybody, now let us solve this with the help of simple trick. Okay. Now we will solve this even more in an easy way. Okay. We will solve this with an easy way. Right. Okay. Got it? Chalo. Now, sum of bond order of CO and NO positive. Acha. What about CO? CO. CO means you have, carbon is having how much atomic number? It is having 6. So it is 6 plus 8, oxygen is 8, so it will be 14 electrons. When you have 14, the bond order is 3. Arey ma'am, very simple ma'am, it is so very, very simple, right? Okay, so now what about NO positive? Now this is a very, very important compound, right? I'll tell you also why this is important, okay? I'll give you 2 important compounds here. Now, see this thing here. Why this is important, we will see that. Okay, this will not be solved with the help of trick, right? Tricks are not applied everywhere. So I'll give you 2 examples here where the trick is not applied. So here only I am writing the exception of this trick. Not exception, there is a proper logic for that. Okay, it's just that I have given you a simple way, but I have to also tell you that where it is not applied. I am giving you the trick. You are just cramming that trick, but in the exam, I have not told you that this trick is not applied here. Like, ma'am, what you did to me? Ma'am, why you did this with us? You told us, but you didn't. It's like half information is the wrong information, right? So having the half information, it will cut down your marks. Okay, so I am going to give you 2 important formulas here where you are going to see that the answer is different. Okay, so first we are going to solve NO. First, we are going to solve for NO, N2. Okay, firstly, let us solve for N2. Ready? Firstly, let us solve for N2 negative. Acha. Why I am saying this? I'll tell you why I am saying this. N2 negative. Acha, how many electrons? It is having 7 plus 7 plus 1 electron it is gaining. So, it is having 15. Now, students will get excited. They will say, ma'am, 15 electron, more than 14 electron, ma'am. Just apply this thing, ma'am. Just apply 1, 2, 2, 1. I'll say, no, don't apply this. Can you tell me the reason why I said, no, don't apply this? Why I said, don't apply this? Reason is, you have to see whenever you have a cation or an anion, you have to see originally how many electrons it had. Origin, what is the origin? That is how you will apply the trick. Now, whenever you see a cation or an anion, I would ask you that go through detailed method. Only then you will get the correct answer. This is not board exams. We are just apply the trick, right? You should also know where not to apply the trick. So whenever you see a cation or an anion, then stop there and see what is happening. Mostly you have these two exceptions only. Other to trick will be applied, right? So now here originally N2 has 14 electrons. For N2 you are applying 2 1 2 1. When N2 is gaining 1 electron, right, then you have 15 electrons, because originally it is made from N2 which is having 14 electron. So it will be 2 1 2 1, because guys it was originally N2 only. The orbitals were for N2 only. You have just gained 1 electron here, right? It's not like you will gain 1 electron and everything will change. Like this will not happen. Okay? Yes? Yes. Chalo. Got it, guys? Everybody in the chat box. Everyone in the chat box got it or not? Yes? Now, here what will happen? Here what will happen? You will apply this 2 1 2 1 only. That means 2 1 2 1. Here what will happen? The electrons. Yes, smash the like button, guys. Yes, target, because you have liked on the previous session, but this session you have not liked. Hai? That's not my fault that the net got disconnected, right? So you have to give me reward for that, and the reward is not 100, the reward is 200 plus likes I want, because so much energy I am putting into this, right? Now you have 2 1 2 1. That means from 15 how many electrons you will subtract? 18, right? So here the answer will be 15 minus 8. So how many electrons, guys? 15 minus 8, you will have 6 7 electrons here. So it will be 1 2 3 4 5 6 7. So answer will be, this is your pi star, right? So answer will be, bond order is going to be 6 minus 1 by 2, that is 5 by 2. The answer is going to be 2.5. Okay, bond order is going to be 2.5. Okay, bond order is going to be 2.5 here. Okay, yes. So now here, wait a minute, let me see. 1 2 2 1. For more than 2, if you apply for 1 2 2 1, then what you will get? Let me see if the trick is applicable or not. 1 2 3 4 5 6 7. The trick is applicable, but it's not everywhere it will be applicable. Here too you are getting the same answer only, but it's not always. So I don't want to take any risk here, right? So NO positive, N2 will have 2.5 only, right? Okay, what about NO positive? Let's talk about NO positive here. NO positive. Nitrogen is having 7, oxygen is having 8. So it will be 7, 14, 15. 15 electrons originally, minus 1. Minus 1. Right? So here you will have 14 electrons. But you will apply here which one? Because originally it had 15 electrons. So you will apply 1 2 2 1. Okay? Even though it is having 14 electron, but you will apply 1 2 2 1. So it will be 1 2 2 1. So here it will be 14 minus how many electrons? 14 minus 8 electrons for KK star. So answer will be 6 electrons here. And this is your pi star. So 1 2 3 4 5 6. Now the bond order is going to be 6 minus 0 divided by 2. So answer is going to be 3. Okay, so this is having 3 bond order. This is having 3. So 3 plus 3, it will become 6 is the correct answer. Okay, 6 is the correct answer. Okay, yes, ma'am, isn't it 3 for 14 electrons? Definitely it is 3 for 14 electrons. I am telling you something else. I am telling you that when you have NO positive, originally it is having 15 electrons, then you will apply 1 2 2 1. You will not apply 2 1 2 1, because originally you have to see how many electrons it had. Okay, got it? Ma'am, just one electron from zero. Is it right? Yes. From oxygen. Yes. Is this thing clear to everybody or not? Is this thing clear to everybody or not? Now let us apply the same thing here, right? Now so directly we will see H2, I'm writing He2 positive, O2 positive, then you have N2 2 negative, then you have O2 2 negative, then you have F2 Ne Ne positive, Ne2 positive, B2, right? Now you need to tell me what is the bond order by calculating the electrons. We have seen the exceptions as well. We are not to apply that, right? Okay, so now let us see this. You have H2. H2 means what? H2 means what? Everybody in the comment section. H2 means what? Yes, everybody in the comment section. H2 means what? Yes, very good. So H2 means 2 electrons here. This means 2, 4, 4, 3 electrons here, right? This means 14 electrons. So when you have 2 electrons means the bond order is going to be, I'll just tell you bond order. Right, firstly let us write the electrons. So it is going to be 16 electrons minus 1, total 15 electrons. Here it is going to be 14 electrons plus 2, total 16 electrons, right? So it is going to be 16 electrons plus 2 electrons, 18 electrons, right? So it is fluorine is 9 to 18 electrons. Then again here you will have uh, 9, 20, 19 electrons, right? So here you will have what? Here it is B2. So B2 is going to have how many electrons? It is going to have your hydrogen, helium, lithium, beryllium, boron, 5 to 10 electrons, right? So now just remember one thing, right? When you have 2 electrons, that means you will have sigma 1s2. So the electrons is going to be only in the bonding situation. So bond order, they are saying the number of species from the following which are paramagnetic with bond order equal to 1. Array, they are also telling you paramagnetic. Firstly, calculate which have bond order 1. Then we will see out of that which is paramagnetic. Right, firstly we will see which of the following is having bond order 1. Then we will see that which of the following, which of that is paramagnetic. Right, so here H2, it is sigma 1s2. So it is going to be 2 minus 0 by 2. The bond order is going to be 1. Bond order is going to be 1. It is having 3 electrons, so it is going to be sigma 1s2, sigma star 1s1. Right, so it is going to be 2 minus 1 by 2, that is 1 by 2, it is 0.5. Right, so it is 0.5, it will not exist only. This molecule will not exist only. 0.5 is very unstable. 0 means, 0 bond order means that will not exist. 0.5 means that will exist in a very unstable situation. Right, O2 positive. For 15 electrons, I already told you, it will be 2.5, right? Just 14 means 3. 15 means subtract 0.5 from that. 16 means you have to subtract 2 times 0.5 from that. So it will be 2, right? Here the answer is going to be 18 electrons. 18 means it is going to be 1, right? 18 means it is going to be 1. Then here also it is going to be 1. Here 19 means it is going to be again 0.5. Subtract 0.5 from that, it is 0.5. Further you have to subtract, na? So further you have to subtract. So if you talk about 19, subtract 0.5, it will be 0.5, right? So 19, it is 0.5. What is B2? Again, it is going to be 1. Hai na? For B2, it is going to be, wait a minute, 1, right? Okay. So for B2 also, it is going to be 1. So now you have 4 things. One is B2, F2, then you have O2 2 negative, then you have H2. These 4 you have to draw the diagram to see which is paramagnetic, which is diamagnetic, right? Okay, so let me draw the diagram for H2. I'm just dividing this into 4 parts, right? So how to solve that in a very fast manner? So this is H2, then you have F2, then you have B2, then you have O2 2 negative, right? Now guys, see, unpaired electrons you need to see. H2 is having 2 electrons, right? So it will be sigma 1s. It will be sigma 1s, right? This is sigma 1s. This is sigma star 1s. We know that 2 electrons means it is 1, 2. Now it is having no unpaired electrons, so it is diamagnetic. It is diamagnetic, right? What about B2? B2 means total it is having 10 electrons. 10 minus 8 electrons means it is having 2 electrons. Now total 10 electrons it had, that's why less than 10 electrons means it is going to have 2, 1, 2, 1. Okay. Are you guys able to understand this, what I'm doing here? Right? Okay, I'm giving you a quick way of solving the questions. 10 minus 8 electrons, 2 electrons. And how to fill that? It is 2, 1, 2, 1. 2, 1, 2, 1. Right? Just write this here. It will be 1, 2 electrons you have to fill. Definitely it is paramagnetic. Right? It is paramagnetic in nature. Got it? Right? Okay. Very good. Very good. Very good. So it is having paramagnetic nature. Achha, what about F2? What about F2? F2 is having how many electrons? 9 is the atomic number. 2F means 9 to 18 electrons. 18 electrons, ma'am. Okay. Simple trick is subtract 8. Just directly subtract 8. Okay, that is a trick. So now you have 10 electrons. Acha. Total originally you had 18 electrons. More than 14. That means 1, 2, 2, 1. Okay. So here it is, the trick is going to be 1, 2, 2, 1. 1, 2, 2, 1 means 1, 2, 2, 1. 10 electrons you have to fill here. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. That means all the electrons are paired here. Very good. Odd electrons, 10 electrons, 14 electrons, very good. So it is going to be your paramagnetic, it is going to be diamagnetic, right? Diamagnetic. Okay. Now, next thing is, or you can just directly write it, right? But why I am drawing the diagrams for you, so that you can also practice these things. Now you have, originally you have 16 electrons, minus 2 it is 14. So here you will have, see, oxygen, O2 will have 16 electrons. That means you have to apply it 1, 2, 2, 1 only here, right? But here in this molecule, in this ion, you have 16, 18 electrons, right? So it will be 1, 2, 2, 1. So here 18 minus 8 is 10 electrons. Again, the same thing will happen, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, it is diamagnetic. So answer is going to be B2 is going to be your paramagnetic with bond order 1. So this is going to be the answer. How many? Answer is 1. Okay. So here you can write the answer is going to be B2, which is paramagnetic and bond order is 1. Okay. And bond order is 1. Okay. Got it? Yes, bacha. Okay. Now, next is number of molecules, species from the following having one unpaired electron is one unpaired electron they are asking, right? Okay, let's do the same thing. Now, let's do even more easily how to solve this. So, in a long way, I have told you how to solve paramagnetic, diamagnetic. So, in a simple way, number of molecule species from the following having one unpaired electron. This you have to make the diagram to see that how many unpaired electron you have. So you have O2, O2 negative, NO, CN, O2, 2 negative. So we have already seen the diagram. Firstly, let us see O2, O2 negative and these three things. O2 is what? 16 electrons. 16 minus 8 is what? You have 8 electrons. You have 8 electrons left. So here always you will draw 1, 2, 2, 1. So let's draw 1, 2, 2, 1. For O2, what we will do? 8 electrons we have. So it will be 1, 2, 3, 4. So 8 electrons means all are paired, right? So all are paired means it is going to be 1, 2, 3, no, all are not paired, 1, 2, 3, 4, 5, 6, 7, 8. Now you have two unpaired electrons here, right? Two unpaired electrons you have here, right? Two unpaired electrons you have here. So you can write it is having two unpaired electrons, right? What about O2 negative? O2 negative. That means it is going to have 17 electrons. So it is going to have 9 electrons in total. So here it will be 1, 2, 3, 4, 5, 6, 7, 8, 9. Now you have one unpaired electron. So you can write here that here you have one unpaired electron for O2 negative. If you have O2 2 negative, O2 2 negative, 16, and you are adding 2 electrons here, so it will be 18. 18 minus 8 is again 10 electrons. That means here you will have one more extra electron. It means this is having no unpaired electron, zero unpaired electron, right? Zero unpaired electron, right? Okay. Now, next is this we have completed. What about NO and what about CN negative? What about NO and what about CN negative? Everybody, what about NO and what about CN negative? Let's do this here. Okay, let's do this here. NO and NO is what? NO means 7 plus 8 electrons, 7 to 14. 7 to 14 plus this 15 electrons in total. That means it will be 1 to 2, 1 only, right? 15 electrons you need to fill here. How you will fill 15 electrons? 1, 2, 2, 1. 1, 2, 3, 15 minus 8 you will fill now. So answer will be, why 8? Why we have subtracted 8 from here? Why we have subtracted 8? So 5, 6, 7, it is going to be 7 electrons. So 1, 2, 3, 4, 5, 6, 7. Can you see again it is having one unpaired electron? So it is also having one unpaired electron, right? What about CN negative? CN is having 6, carbon 6, nitrogen 7. Answer is CN negative means 1 electron it is adding. So it is 7 to 14, 14 electrons, right? That means less than, see CN negative they are talking now. CN was having 13 electrons. That is 6 plus 7, right? That is 13. 13 means less than 14. So answer we will have here is 2, 1, 2, 1. Here it will be 1, 2, 2, 1. 2, 1, 2, 1 means 1, 2, 1, 2, 1. So here it is going to be 14 electrons. But we are going to subtract 8 before only for KK star. So here it is going to be 6 electrons we have to fill. 1, 2, 3, 4, 5, 6. No unpaired electron. So the one which is having only one unpaired electron is only one unpaired electron. One unpaired electron is with O2 negative and NO. Got it? O2 negative and NO. Right? Okay. Yes. Very good, Ultra. After 1 hour of 1.5x session, I got here. Very good. So answer is going to be 2 molecules, right? That is O2 negative and your NO are having number of unpaired electron as 1. Got it? Okay. Yes. Next topic is very small topics we are left with. Major chunk of chemical bonding we have done. After chemical bonding, we will take break and today only we will complete coordination chemistry. Okay? Yes. Now let's do dipole moment, right? What about dipole moment? Dipole moment means this is basically represented by this mu, right? So for example, you have CO2 molecule, right? So it is going from negative to from positive to negative side. So this is less electronegative, so it will be from this side. less electronegative, it will be this side. It will cancel each other and mu is going to be 0. This is how you will understand the question of dipole moment, right? So here the answer is going to be, the first question on your screen is, given below are two statements. One is labeled as assertion and other is labeled as reason. NH3 and NF3 molecules. So you have NH3 molecule, I'll just draw in front of you. This is NH3, tetrahedral shape it is going to have. NF3 is this. This is NF3. This is NF3, right? This is NF3. Now, what you will observe here, that always it is from positive to negative, right? And from atom to lone pair, right? So here the direction is from atom to lone pair, and here it is from positive to negative, because this is, hydrogen is electropositive as compared to nitrogen, right? So it is from positive to negative, from positive to negative. That is why it will add, just like you add the vectors, it will add. But what about this one? In front of fluorine, nitrogen is electropositive. So this is from positive to negative, from positive to negative, from positive to negative. This is from positive to negative. Here the resultant will be this and this. They will cancel, not exactly cancel out each other, but some amount will cancel, and mu will be less, right? Mu will be less as compared to this, because here there is no subtraction. Here you have the subtraction. That is why mu is less here, right? So now let us see the question. NH3 and NF3 have pyramidal shape, definitely, with a lone pair of electron. The resultant dipole moment of NH3 is greater. This is true. In NH3, orbital dipole due to lone pair is in same direction. Yes, that is in same direction, right? Right, as a resulting dipole. Fluorine is most electronegative element, right? Yes, that is also true. So this reason is also true. So we can say that both, wait a minute, in NH3 orbital, in NH3, see, both statements are true only. We have to see whether it is explaining that or not. In NH3, the orbital dipole due to lone pair is in the same direction as a resultant dipole moment of NH. F is the most electronegative element. So they have not exactly given you the reason here, right? Exactly the reason is not given, but both the statements are true. So answer will be B is the correct answer. Why A they have written as the correct answer? They are taking this as the reason only. But according to me, the reason should be well explained, right? They are taking this as a reason only, that yes, NH3 orbital dipole moment due to lone pair is in the same direction. But they should have written one more line here. But in NF3, it is in the opposite direction. Then I would have said that, okay, this is the exact reason. But yes, they have given you a hint of the reason. And they are saying that we have given the total reason. So A is the correct answer, right? But I would say proper reasoning is not given here, right? But yeah, hint of reasoning they have given, right? Next is, given below are two statements. Since fluorine is more electronegative than nitrogen, okay, fluorine is more electronegative. The same question is repeated, right, in a different form, right? Same question is, since fluorine is more electronegative than nitrogen, the dipole moment of NF3 is greater. This statement is false. NH3 is greater. Wait a minute. Wait a minute. So here it is, in NH3, the orbital dipole due to lone pair and the dipole of NH are opposite direction. But NF3, the orbital dipole due to lone pair and the dipole moment NF3 are in the same direction. Again, this is false. In NH3, it is in the same direction. In NF3, it is in the opposite direction. This is also false. So both statements are false, right? So answer B is the correct answer, okay? B is the correct answer. Got it? Yes, guys. Next is, they are saying that number of compound species from the following which have non-zero dipole moment. First thing is, you should know the structure, right? Then you can easily draw the dipole moments here, right? So firstly, I'll tell you the structure here. The polar molecules, the non-polar molecule, first I'll tell you the, here it should be mu is equals to 0. Okay, so the polar molecules, right, where mu is not equals to 0, right? So that is NF3H2O. Reason being, NF3 is what kind? NF3 is like this. Nitrogen, F, 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 and this is lone pair. That is why it is not entirely cancelled out. H2 is like this. Oxygen, this is H, this is H, this is lone pair, this is lone pair. That is why it is not entirely cancelled. H2 is also like this. H2S is also like H2O only. Right? HBr is H and Br. Definitely it is not getting cancelled. Definitely it is not getting cancelled anywhere. Right? Here also it is not getting cancelled. It is not totally getting cancelled. NF3 is not totally getting cancelled. Right? It is not like mu is 0. Here also it is from this side, then from this side, then this side. It is getting added up only. Positive to negative towards the lone pair. Then you have HCl. HCl and HB are of same kind only. So it will have mu not equals to 0. What about these molecules? Let us see the structures. If you see BeCl2, it's like this. It's a linear molecule, right? BCl3, it's a trigonal planar molecule. Okay, XCF4, it's XC, and then you have F4 as this. This is F, this is F, this is F, this is F, and this is your 1, 2, 3, 4, 5, 6, 7, 8, like this. Then you have CCl4. CCl4 is tetrahedral, 4 same lone pairs of same atoms. H2 is like this. Now see this thing. How they are getting entirely cancelled out. Positive to negative entirely. Here you should also add CO2, right? CO2 should also be in this part only, right? Entirely getting cancelled out. Entirely getting cancelled out. This will give you a resultant like this, right? Which will cancel this particular Cl, right? So it will cancel out. Here also, it will give you this thing, this thing, this thing, and this thing. They both will cancel each other. See, it's like a square planar structure. It's like a square planar structure like this. This is going to cancel this. This is going to cancel this. And the lone pair here is going to cancel the lone pair here. Right? So that is why mu is going to be 0. In tetrahedral also, if you see the 3D structure here, these three will make a resultant, right? Which will be somewhat here. So this resultant is going to cancel this one. So it's basically in vectors you must have studied, right? So again, they are going to cancel. This is C. Okay, so it is going to cancel. Here, so definitely it is going to cancel each other. This is the same molecule, right? When you have same molecule like homoatomic molecule, then it is going to cancel each other, right? There is no electron negativity difference only. So how come they will have the dipole moment, right? So here, this will cancel out each other again. So they will have mu is equals to 0. In these molecules, mu will not be equals to 0. Is that clear to everybody? Is that clear, guys? So number of compounds with non-zero dipole moment, 1, 2, 3, 4, 5. 5 is the correct answer. Got it? Yes, everybody. Now, next is, which of the following molecule has maximum dipole moment? Can you tell me which of the following has maximum dipole moment? See, NF3, so we know definitely it is less than NH3. Right, CH4 is also getting cancelled with each other. Here, so mu is equals to 0 only. In PF5 guys, PF5 also it's a trigonal pentagonal structure. Right, it's a trigonal pentagonal structure. Right, here also mu is 0. Firstly, what will happen? You will have a resultant here, you will have a resultant here which will cancel each other. Right. So this is the thing, right? You will have this as the resultant. These are the three. Firstly, I am talking about the trigonal structure, right? Trigonal structure. This is the trigonal structure. So in the trigonal structure, what you will have? In the trigonal structure, firstly, you will have resultant here. It will cancel each other. This two will form a resultant. it will cancel this one, right? Then other two are to definitely perpendicular to each other. They are to directly going to cancel each other. Directly it will cancel each other, right? So mu is going to be 0 here as well, right? So definitely NF3, again third time the same question is asked, right? NF3 is less than NH3. So answer is going to be NH3. So third time the same question they are asking, the same question, right? Okay. So this is a very, very important question. Okay. Next is choose the polar molecule from the following. You have to choose the polar molecule here. Polar molecule, guys. Polar molecule. Yes, everybody. Polar molecule. What is the polar molecule here? Anybody in the comment section? CO2, we have seen mu is 0. CCl4, mu is 0. Here also mu is going to be 0 because it's a symmetry, so everything will cancel out each other. If you see this, H, 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 H. So the dipole moment will be cancelled out. So mu is 0. So they are asking polar molecule where mu is not equals to 0. So this is where mu is not equals to 0. D is going to be the correct answer. No. CCl4 will also cancel out all the dipole moments, right? Okay. Now, what they are telling you here, wait a minute. The total number of molecules with 0 dipole moment, I think I have written the answer here only by mistake. Chalo, no worries. The total number of molecules with 0 dipole moment among CH4, BF3, H2O, HF, NH3, CO2 and SO2. You have to see the total molecules here. So, 0 dipole moment. See, CO2 will have 0 dipole moment. This will not have. HF will not have. H2O will not have. BF3 will have 0 dipole moment. Reason being because it's a trigonal planar structure. It will cancel out all the dipole moments. CH4 is going to have a dipole moment 0 because it is a tetrahedral structure. Everything is going to cancel each other, right? SO2 is like this, right? SO2 is like this. So here it is also, wait a minute, why we have not written SO2 here? SO2 also should cancel here, na? So they are asking about with 0 dipole moment. SO2 will also have 0 dipole moment. 1, 2, 3, 4. Right? So answer is going to be, wait a minute, why SO2 will not have 0 dipole moment? Wait a minute, it is existing as 1, 2, 3, sp2 hybridized. CH4 has, BF3 has, CO2 has, है ना? SO2 should also have 0 dipole moment, isn't it? Isn't it? What do you think? Why we have? Let me recheck this. SO3, oh, so sorry. It is SO2. I'm so sorry. I'm not so sorry about it. It is SO2, guys. Ma'am, you have drawn SO3. I'm so sorry. That's why I was thinking how. Okay. So SO2 will not have 0 dipole moment, right? But SO3 will have. So they have asked us SO2 here. So SO2, what is the structure of SO2? It is going to be 2 bonds here, 1, 2, 3, 4, and 1 lone pair over here, right? So this is the structure of SO2, right? So SO2 is definitely going to have a lone pair, dipole moment, right? It is not entirely going to cancel out each other because it's not the same thing. So if it would have been SO3, then dipole moment would be 0. But in SO2, dipole moment is not equals to 0. So the answer is 3 only, okay? So these 3 have symmetrical structure leading to mu is equals to 0. Okay, got it? Yes, everybody. Now some miscellaneous questions from chemical bonding, right? Usually hydrogen bonding or maybe some ionic structure. Very rarely they will ask you, but like the maximum that we have done, right? From where definitely the question they are going to ask is, we have seen VBT, we have seen same kind of question they are asking from MOT, same kind of question they are asking from VBT, Vesper and hybridization, and same kind of question you are asking from dipole moment, right? So that means this is what you need to focus on, right? Okay. So now miscellaneous, that means it's like they can ask you this, but you don't need to do these topics individually, right? So arrange the bonds in order of increasing ionic character in the molecule. So increasing ionic character, more is, just remember, more electron negativity, more is ionic character, more ionic character. So here electron negativity is minimum in N2. So answer will be minimum for N2 because it's the same atom. So there is no electron negativity difference. So this will be eliminated, this will be eliminated. Maximum electron negativity difference is between Li and F. Lithium belongs to S block. Fluorine belongs to halogen. Maximum electron negativity difference. So then you have K2. Now I have to see between these two things, which has more electron negativity difference. See, oxygen, sulfur, fluorine, chlorine, which has more electron negativity difference. So fluorine is the highest electron negative element. That is why it will have more electron negativity difference as compared to this. So answer will be C is the correct answer. Got it? C will be the correct answer. Right? Okay. Next is they are now saying that you have two things, assertion and reasoning. pH3 has lower boiling point than NH3. Now this is a very, very important concept, okay? Very, very important concept. pH3 has lower boiling point as compared to NH3. See, NH3 has hydrogen bonding. That is why it has more boiling point, right? So this it is true. Reason is, in liquid state, NH3 is associated through van der Waals forces. This is not true. NH3 is associated with hydrogen bonding, right? So that's why assertion is correct, reason is incorrect. Reason is incorrect. So answer D is the correct answer. Okay? D will be the correct answer here. Very good, very good, very good. I'm so happy that you guys are giving the answers. I'm so happy about it. So when you will give the answer, right? So it will be very easy for you to give the answer in the exam also, right? Okay. So I'm also doing this in a very fast manner so that you don't feel like, ma'am, you are to wasting time on one question only, right? So here, next is the correct statement. The correct statement about hydrogen bonding is, hydrogen bonding exists when hydrogen is covalently bonded to highly electron negative atom, right? Okay, hydrogen should be covalently bonded with some electronegative element, then only hydrogen bonding is possible. That is true. Intermolecular hydrogen bonding is present in orthonitrophenol? No. Intramolecular is present in orthonitrophenol. Intramolecular is present here between one molecule. Intramolecular is present in HF? No. In HF, you have intermolecular hydrogen bonding. The magnitude of hydrogen bonding depends on physical state of the compound. Okay, that is true. Hydrogen bonding has powerful effect on structure and properties of the compound. That is also true. So, A, D and E are true. A, D and E are true. That is, B is the correct statement. Okay. B is the correct statement here, right? Okay. Next we have, select the compound from the following that will show intramolecular hydrogen bonding. Intramolecular, that I told you now only. Intramolecular is shown by which of the following compound? Everybody, I to expect everyone can answer this. Everyone can answer this. This is so like very simple question. Very, very simple question. Okay. Very good. D is the correct answer. Here you will see intramolecular hydrogen bonding. Very good. Very good. Now, next is, which of the following is least ionic? They are asking that which of the following is least ionic in nature, which is not ionic in nature. You have BaCl, AgCl, KCl, CoCl2. Least ionic means where electron negativity difference is very less. See, Cl, Cl you have Ba, K, these two to belongs to, these two are belonging to your S block. So they will not be least ionic, they will be more ionic. What about Ag and cobalt? Ag positive, cobalt 2 positive, cobalt 2 positive. So here basically, as one student was saying, Fajan's rule. So Fajan's rule will tell you the covalent character, but for ionic character, what you need to see, when you have less charge, right, more will, less charge means less cationic charge means your less will be the covalent character, more will be the ionic character, right? What is Fajan's rule? Fajan's rule means more is the positive cation, more will be the covalent character, that less will be the ionic character. So here answer is going to be AgCl, right? Why? Because it has less cationic charge. That means more an ionic character, right? Okay, so answer is going to be B. Okay, answer is going to be B is the correct answer. Okay. But they are asking you the ionic character, not the covalent character. Wait a minute. Least na. Oh, so sorry. Fajan's rule is basically, Fajan's rule is, wait a minute. Ionic character, no, they were telling us about the covalent character. So, more the polarizing, just give me a second, more the polarizing power of negative. More the charge, no. So more the charge, more is the covalent, less is the ionic. This is Ag positive, है ना? This is CO2 positive. That means it is having less charge here. So more charge means more charge. Oh, so sorry. Yes. More charge means you have more ionic character. I'm so sorry about it. I just got confused between covalent and ionic character, right? So more charge means you have the more ionic character. Okay, less covalent character, more ionic character. So here you have more charge, so it is having more ionic character. Yes, it is having more ionic character, and in that way this will have less ionic character, So answer is going to be B. Okay, yes. So basically this is based on your Fajan's rule. Okay, so more is the ionic character, more is the charge. If they ask you the covalent character, then it will be opposite. Okay, it will be opposite of this. If they ask you the covalent character, then this will have the less covalent character. Okay, yes, I am giving you break only, guys. Even I am hungry, guys. I'm hungry. Even I have not had my dinner. Okay, the correct increasing order of bond angles BF3, E3, I think it should be F3, right? PF3, CLF3, the correct increasing order of bond angles. Very important question regarding bond angles. I think this is the last question. So I'm going to give you one very simple way of telling the bond angle, okay? One very simple way of telling the bond angles. 3 steps you have to use for bond angles, okay? 3 steps you have to use. First step for bond angle is check hybridization. Check hybridization. See, you will have either SP or SP2 or SP3, right? So SP is going to have 180 angle, this is going to have 120, this is going to have 109 degree. So it will be the bond angle. Firstly, if hybridization is same. Second step is if hybridization is same, then check the lone pair. So lone pair, bond angle is inversely proportional to the lone pair. Bond angle is inversely. If hybridization is same only, then you will check this, okay? Bond angle is inversely proportional to the lone pair. It's a very important thing, okay? Third is if lone pair is also same. If lone pair is also same, lone pair and hybridization are also same, then what you have to do? Then the third step is when bond pair and hybridization both are same, then what you have to do? When bond pair and the hybridization both are same, then simply you just check what is different. What is different? If central atom is different, central atom is different, or surrounding atom is different, or surrounding atom is different between these two. Best though, I'll tell you, you will get your answer in these 2 points only. First and two. This will be the, if they ask you very tough question, right? This though you don't have to go through. Firstly though, you will get the answer in first 2 points only. Central atom and surrounding atom, just give me the answer. If central atom is different, then more the electron negativity of central atom, more is the bond angle. If surrounding atom is different, more the electron negativity of surrounding atom, less is the bond angle. This is a full 3 steps where you can calculate the bond angle of any series that is given to you. Right? Okay. Yes. Anything what is given to you. Now guys, see this thing. Very important. Very important. Firstly, let us check the hybridizations. Boron is having BF3. It is having 3 sigma bonds. That means it is having sp2 hybridization. PF3, it is having, phosphorus is having 5 electrons minus 3. It will have 2 electrons. That means 1 lone pair. That means it is having 3 bond pair plus 1 lone pair. That means total 4. That means it is having sp3 hybridization. What about ClF3? What about ClF3? ClF3 is having 7 electrons minus 3. It is going to be 4 electrons. That means 2 lone pairs. That means it is 3 bond pair plus 2 lone pair. Right? So it is going to be 5. Right? So angle is going to be between CF3. You have to predict the angle, right? So this is your trigonal pentagonal geometry, where if you have 2 bond angles, 2 lone pairs you have replaced. So it will have a 90-degree angle. Got it? Why it will have the 90-degree angle? Right? Why it will have the 90-degree? See, simple thing. Hybridizations are different. So very simple it will become. It is 120 angle it will have. This is having 3 bond pair, 1 lone pair. That means 4. So this is having basically, wait a minute, 3 bond pair, 1 lone pair. Na? So it is going to have sp3 hybridization. That means somewhat it will be near to 107 or something. Less than, it will be less than 109 because of this lone pair bond pair repulsions. This ClF3, it is pentagonal. So when in pentagonal, when you replace 2 lone pairs, you will have the T-shaped geometry. It will have 90-degree angle, right? So it will have 90-degree angle. So maximum is for BF3, right? Maximum is for BF3. Then you have PF3. Then you have ClF3. So answer should be B. Okay, answer is B. Got it? Answer is B. Got it, guys? Okay, very good. Option B is the correct answer. Now, guys, we have done chemical bonding and we are left with coordination chemistry, right? Okay, so shall we do it today only? Because I have promised, so I want to do it today only. So do you also want to do it today? Right? Do you also want to do it today? Let's take break for 15 minutes. Let's have our dinner. Right, let's have our dinner. Let's take break for 15 minutes. So it's 10:13. I'll see you at 10:30 p.m. 10:30 p.m. I'll see you all. And we are going to finish off coordination chemistry today itself. Right? Okay? Yes. Oh, data is over. So you can watch the recorded version. Right? So in the similar way, are you satisfied with the chemical bonding? Are you satisfied with chemical bonding? How we solved the questions also, how we went through the concepts also, right? Okay. So the same way we are going to do it for coordination chemistry. But I want to see the same strength here, right? I want to see the same strength. I don't want you guys to give up here, right? I want to see the same strength in the chat box after 15 minutes also, so that we can complete this today. Okay, so see you all in the I should join again. Yes, definitely. I'll join back at 10:30 p.m. where we are going to complete coordination chemistry today itself. See, guys, we are just 30 days away from that, right? Yes, maybe 40 days you can say that, but that those 10 days will just pass by like this, right? So time is very less, time is very precious. That's why utilize this time, right? I have already done the hard work for you all, right? You just have to see and watch this lecture. That's it. Okay, yes, after break, coordination chemistry. Okay, then see you at 10:30. Okay, yes. Hello, hi everybody. So, welcome back. I hope you all had your dinner and your ma'am also had her dinner. So, let's start with coordination chemistry, like just the way we did. Back with same energy, ma'am. Yes. My carbohydrates are getting converted into glucose in the form of energy. है ना? Chalo. Now, let us start the session again, right, with coordination chemistry. Now, if you talk about the coordination chemistry, usually the questions will be asked from VBT or CFT, right? Very rarely, isomerism is also a very important topic, but the questions will be asked, but only very rare chances. Very rare means if you talk about this is having 2x amount of chances, then isomerism will have x amount of chance, right? But these three are the main important topics from where the questions are asked, right? Okay, so now let us see. That's the first law of thermodynamics. Okay, I am giving you the energy. Okay, now let us see, the first topic is ligands and color of compounds. So this is something miscellaneous from where the questions are frequently asked based on the color of the compound. So let us see firstly those kind of questions. Okay, so the first question here on your screen is, which of the following complex is homoleptic in nature? What do you mean by homoleptic? That means same kind of ligand, or same ligand it is having, the one which is having the same ligand. See, such simple question has been asked, right? So the answer is A is the correct answer, which is having the same ligand. Others have different ligands. So answer is A is the correct answer. Then next you have, given below are two statements. They are saying that given below are two statements. Statement 1 is NCH3 thrice and PCH3 thrice can act as ligands to form transition metal complexes. Yes, they can act as ligands. So this is the true statement. They both can act as ligands because both have lone pairs, right? As N and P are same group, are from the nature of bonding of this and this are always same with transition elements. This is false. See, nitrogen and phosphorus have different electron negativity, right? So their bonding, their donation power is going to differentiate, right? So that is why they will not have the same kind of bonding nature with the compound. So the answer B is going to be false. So statement 1 is correct, statement 2 is incorrect. So answer A is going to be the correct answer. Okay? Okay, bye bye. Bye bye, Gautam. Charge. You should always charge your phone. Okay. So now match list 1 with match list 2. This is based on the colors, right? So here how to do hit and try. Let's see that, right? So first is FeCN5NOS, right? Then you FeCN 2 positive. Then you have NH4 thrice PO4 12MOO3. Basically, this is, you can say that this is a question of practical chemistry. This is a question, you can say that this is a question of qualitative, quantitative analysis, because we can see all these compounds there as well, right? So Prussian blue, firstly, so you have to see Prussian blue, right? So Prussian blue is the first compound that you can see, right? Then you have blood red compound. This is going to be your blood red compound. This is going to be yellow compound. This is going to be third. So I'll say A is 3. A is 3. A is 3. B is, wait a minute, B is violet. Yeah, it is violet. Yes, B is A. Then C is 2. C is definitely 2. Okay, C is definitely 2. So this is Prussian blue, right? Then this is your red color. Okay, this too you have to remember only, right? So this is blood red color. This is having violet color and this is having yellow color, right? So answer is A is the correct answer. So A will be the correct answer. So how, basically these are, when you will study qualitative, quantitative analysis, purification, there you have all these in your salt analysis, right? Okay. So basically all these are coordination compounds only. So you can study, you can say that this is a question of coordination chemistry, or this is a question of practical chemistry, or this is a question of quantitative analysis, right? So, but you should know these are it's not like they can ask you randomly they can ask you anything, right? Any other color, right? They will ask you some compounds which are very important in your syllabus, right? So, these are important compounds, right? What to explain? Yeah, this is to just color. This is the nothing to explain here. This is the color. It's yellow in color. It's blood red in color. It's violet in color. It's Prussian blue in color, right? It's just the colors, okay? So, next is statement 1. Here it is, dimethyl glyoxime forms a 6-membered covalent chelate when treated with solution of NiCl2 in presence of NH4OH. Now guys, as you can see, I'll just show you the reaction here. This is the reaction. So basically what happens here, you have Ni2 positive. Basically this NiCl2 means you have Ni2 positive ions, okay? Ni2 positive ions. So these Ni2 positive ions, when they react with dimethyl glyoxime, then they form a 6-membered ring, okay? Then they form a 6-membered ring. So as you can see, this is 1, 2, 3, 4, 5. It is forming a 5-membered ring here. It is forming a 5-membered ring. Okay, so basically this is your dimethyl glyoxime. So this is your 2-methyl and this is your full compound. This is the first compound and this is your other compound. This is your other compound. Right? This is your other molecule. They both are having hydrogen bonding here, and with nickel they are forming the coordinate bond, donating the electrons here. So they are forming 6-membered ring here. As you can see, it is forming 5-membered ring. 1, 2, 3, 4, 5. So answer is, first statement is incorrect, right? So first statement is false. It is forming 6-membered ring. Prussian blue precipitate contains both +2 and +3. That is true. If you talk about Prussian blue, right, it will have +2 and +3, both the oxidation state it is going to have, right? So here answer is going to be, the second statement is true. So statement first is false and statement second is true. So answer is A will be the correct answer, okay? A is going to be the correct answer, okay? Yes. PDF in the description, yes, that will be given to you. Yes, that will be given to you. Okay, yes. Now, next is yellow compound of lead chromate gets dissolved on treatment with hot solution. We are saying that yellow compound of lead chromate, right, gets dissolved. Yellow compound of lead chromate gets dissolved in treatment with hot solution. The product of lead formed is, so basically you have lead chromate, right? That is, chromate is what? CrO4 negative. That is your chromate ion, right? Lead chromate with hot basic solution, it is going to give you PbOH4. And here you can see the coordination number is 4. So the coordination number only they are asking you. So the coordination number is 4. So now these are unpredictable. I would say these are, individual questions. So that is why I have put these questions individually, because these are involving reactions also. You never know the same reaction you will see in your exam, right? So that is why I have kept it in ligands and colors, right? So in different questions, then we will go through the theories. In theories, so it will be very simple for you to do the questions, right? Okay. So these are those questions, either you will know or you will not know, right? So that person who have actually seen this question, he will know. The person who is just seeing this question for the first time may or might not be able to solve this, right? So it is a neutral complex with coordination, not a neutral complex, a tetraionic complex is formed with coordination number 4, right? Wait a minute, tetraionic or diionic? Diionic complex is formed. So it is D is the correct answer. Okay, so this is basically reaction involved questions, right? So this can be repeatedly asked to you. The same reaction can be asked to you. Now next is identify the incorrect pair of following. Again, this is a kind of question, either you will know or you will not know, right? So that's why I have put this in this kind of category. So first is photography. It is AGBR, that is true. Polythene preparation, right? Polythene in polymers, you have TiCl4Al CH3 thrice. Haber's process, you use iron. Wecker process, you use PtCl2. It is PdCl2 that is used in Wecker's process. So incorrect is your D, right? So in Wecker's process, you don't use PtCl2, you use PdCl2 that I have taught you in organic chemistry, right? This I have taught you in organic chemistry, right? Now, and this is from your NCRT only. In your NCRT, when you see coordination compound, or I think it is in coordination compound only, you see the last paragraph of your coordination compound. Everything is mentioned there, right? Okay. Now, next is important, that is VBT, valence bond theory, right? So let us see how to solve the questions of valence bond theory. Now we are going to adapt the same pattern of solving the valence bond theory questions, okay? So the first question here on your screen is, given below, they are saying that given below are two statements. A solution of NiH2O6 positive is green in color and this is colorless. You have to see whether there is any DD transition or not, right? Okay, this is what you have to see. That means D orbital is fully filled or not. So first is NiH2O6 positive, NiH2O6 positive, right? And the next one is Ni, this is NiCN4 2 negative, CN4 2 negative. Guys, see how we are going to solve this. There is no as such theory or anything based. If you know the theory of chemical bonding, it will be easy for you to solve this, right? Okay, so I'm going to tell you with the help of questions only how to solve this, right? Now, this is zero. This is a neutral ligand. That means the oxidation state, first you should find. H2, water is a neutral ligand. So it is going to be 0 equals to +2. So X is going to be +2 here, right? X is going to be +2 here. So once you know the value of X, right, that means we are going to solve it for nickel 2 positive. Nickel is basically 28 atomic number. So answer will be argon 18, 4s2, 3d10, 3d8. Now when you are taking out 2 electrons, that means 2 electrons from S orbital will be taken out first. So answer will be 4s0, 3d8, right? Now here also it is going to be same. It is X. What is the oxidation number? Okay, firstly let us calculate the oxidation number. It is X minus 4 is equals to -2. So X is going to be +2 here again. So answer is going to be same. It is nickel 2 positive. So it will be nickel 2 positive. It will be 4s0, 3d8. But here you have H2O and here you have Cn negative. Cn negative is a stronger ligand as compared to H2O. So in this case, you will not have the you will not have the pairing. So it will be 1, 2, 3, 4, 5, 6, 7, 8. But in this case, you will have the pairing because Cn negative is a stronger ligand. So you will have the pairing 1, 2, 3, 4, 5, 6, 7, 8. So here you have no unpaired electron. No unpaired electron for DD transition. Here you have unpaired electrons for DD transition. That is why what will happen? In this case, it will be colored. It will be colorless. It will be colorless. Right? Okay. So here, solution of this is green in color. That is true. A solution of this is colorless. That is also true. So both statements are correct. So answer B is going to be the correct answer. Okay. B is going to be the correct answer. Right. Okay. Both are the correct statement. Next is you have CONH3. Now, same pattern we are going to solve all the questions. Okay. With the same pattern we are going to solve all the questions here. Let us solve this. right? So you have CO NH3 6 3 positive, COF 6 3 negative, right? So you have two questions here, that is CO NH3 6, this is 3 positive, and here it is COF6 3 negative, COF6 3 negative, right? Now after this, what we are going to do, thank you. Now see, first is oxidation state. Okay, firstly we will solve the oxidation state here. This is X. Acha, NH3 is a neutral ligand. Okay, so it is X plus 0 equals to plus 3. So X is going to be plus 3, oxidation state. Here it is going to be X minus 6 because fluorine is a negative ligand. It is having minus 1 charge. So X is going to be plus 3 here as well. Now let us solve this. Cobalt is 27. Saktiv karman fi cobalt 27. Okay, Saktiv karman fi ko nikojan. Okay, so it is 27. It is 4s2 3. Argon I am not going to write again and again. Argon 18, yes. 4s2 3d7, because argon 18 plus 2 of this 4s, it will become 20. Rest we are left with 7, right? So it is 4s2 3d7, right? Now we have to take out 3 electrons from here. 2 electrons from 4 we will take out, right? So it will be 4s0, 3d, 1 electron from this, so it will be 3d6. Here it will be, again I am not going to write this again, it is same thing, so I will just write it 4s0, 3d6. See, NH3 is a strong field ligand. This is a weak field ligand. That is why what will happen here? Here you will have the pairing. Here you will not have the pairing, right? Here you will not have the pairing. Here the pairing will happen here 1, 2, 3, 4, 5, 6. Here no pairing. So what we will do? 1, 2, 3, 4, 5 and then 6. Right? Now let us see what they are asking you here. They are asking this and this are respectively are known as. Now they are saying what they are known as. Guys, VBT. Now, to solve this question, I am writing one thing here, right? Where should I write? I think here. So I am writing one thing here. Just like I wrote for VBT for chemical bonding. So here though it is very, very simple, right? So this is the coordination number. This is hybridization. This is hybridization. If coordination number is 4, then it can be DsP2 or sp3. Any of this. DsP2 means it is square planar. sp3 means it is tetrahedral. It is tetrahedral. Okay? Okay? Acha. If it is having 5, though it will not have. It's not in your syllabus. You have 6 only. 6. It will be sp3, two things, sp3d2 or d2sp3. Now, this is called outer octahedral. This is called inner octahedral. Now, same thing they are asking you, but in a different way, right? Now, guys, as you can see here, the coordination number is 6. That means either it will be D2sp3 or it will be sp3d2. Now, here in VBT of chemical bonding, there we used to see that we used to make the covalent bond. Covalent bond will be formed when one orbital is half filled, other is also half filled. But coordinate bond will be formed when it is empty, right? Because it is a metal complex. It is a metal. Ligand has to donate the electron to this metal, the vacant orbital of this metal. So this needs to be empty. So this is empty, that means it will be D2, rest will be sp3. Rest will be sp3. Here it is fully filled. So it will be sp3 D2. Because either for 6 it can be D2 sp3 or sp3 D2. If D2 is available here, so it will be D2 sp3. If D2 is not available, it will be sp3 D2. Okay? If D2 is not available, it will be sp3 D2. So here, the answer that you are going to write is, they are asking you spin paired complex, spin free complex or spin paired complex. Outer orbital complex, inner orbital complex. Wait a minute. Inner orbital complex, spin paired complex. Outer orbital complex है ना? What is outer orbital? NH3 is outer orbital ना? NH3 is inner orbital. NH3 is inner orbital. So here they should have written inner. This is inner orbital. This is outer orbital. So this is not the correct answer, because here they have written the opposite. They have written outer for this one, inner for this one. This is not the correct answer. Then that means something else is the correct answer. Inner orbital complex, definitely this is the inner. Spin paired complex, spin free complex. See, inner, if you're writing inner, then you have to write outer, right? So this is not the correct answer also. Here you have pairing of electrons. As you can see, this is electrons are paired. Here the electrons are free. So it is basically in a different way they have asked you the question. It is spin paired complex and spin free complex. That means B will be the correct answer. Got it? Right? Okay. B will be the. Why? Inner outer is not mentioned only. The spin paired. How come this is spin paired? There are unpaired electrons here. So this is also not the correct answer. Okay. So don't get confused. Usually students in a hurry, most of the students, they will take this outer inner. Get confused and take C is the correct answer. Okay. So next is, identify from the following species in which sp3 hybridization is shown by central metal. D2sp3, sorry. D2sp3. See, firstly, though, you have to, it is a mixture of chemical bonding and coordination chemistry, VBT. Right? It's a mixture of these two chapters. Right? So here you have SF6. SF6, guys, this is sp3d2. It will not be inner. It will be outer only. sp3d2 octahedral you will form. Right? Here it is, you have 5 bonds here. Right? And 2 electrons. See, 7 electrons minus 5, you have 2. 1 lone pair you will have. So it will be 1 lone pair plus 5 bond pair. It will be 6 only. That is sp3d2 only. Because simple VBT, simple compound, we don't have coordination chemistry. In there you will not have D2sp3. Simple sp3d2. Either here or here. Now this though we have done just now. This though we have done just now, then it is D2sp3. Right? Okay. So same kind of question repeating. Same kind of question they are repeating again. That's why I'm saying that previous year, don't ignore the previous year questions. Right? So this is going to be D2sp3. So answer is A is the correct answer. Okay? 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 Got it? A will be the correct answer. Right? sp3d2, sp3d2, dsp2, ptcl4, they have given this. Acha, this is, they have given it here. Okay, this so I didn't see only. ptcl4, guys, this is going to be your square planar geometry. Square planar geometry. This is dsp2. Okay, this is dsp2. Chalo. Next is aluminium chloride in acidified aqueous solution forms ion having geometry. Aluminium chloride means ACl3 you have, acidified aqueous solution, right? You will have what kind of geometry? So basically OH negative ions will be attached here, right? So if I say this is 6 are getting attached, because it will form octahedral geometry, right? So this is 3 positive, right? This kind of bond it will form, right? Okay, this kind of situation you will have. This kind of ion will be formed, which is octahedral in nature, right? So it will have octahedral geometry, right? Okay, it will have octahedral geometry. So answer is B is the correct answer. So this kind of product will be formed. Again, it is a reaction based question. Directly it can be asked, right? Next is, see, if direct question are asked, then to it is simple. If reaction based question are asked, then to, I know it is like, ma'am, how will I know? It's just like, if you know, you know. Then if you don't know, then just skip that question. But from BBT, where direct questions are asked, from there you can get the answers easily, right? The molecules ion with square pyramidal shape. Square pyramidal shape, guys. Square pyramidal shape. Square pyramidal shape, that means you are going to have D. Either to square pyramidal, na? So you will have, wait a minute, you will have 4 bond pair plus 1 lone pair, right? This you need to have if you want to have square pyramidal shape, right? Okay, so this will not have, this is trigonal bipyramidal. This is also not having this. 4 bond pair we need to have, right? 5 bond pair, so sorry. 5 bond pair plus 1 lone pair. This we need to have for square pyramidal. Square, and there is one pyramid, right? So basically it has 4 here and 1 here, right? So PCl5 is trigonal bipyramidal. BRF5, this is possible. PA5 is also not possible. It is trigonal bipyramidal. So answer will be BRF5. Okay, answer will be BRF5. How? Br is having 7 electrons. See, this is the will not be the answer. Either it will be square planar or it will be tetrahedral, right? So that will not be the answer. That is, so itself is eliminated. That means this is a question of chemical bonding now. Now this is 7 minus 5 electrons it has used. It is 2 electrons left. That means 1 lone pair. 5 bond pair, 1 lone pair. That will make square pyramidal. So C is the correct answer. Okay. C is the correct answer. Got it? Got it, guys? How I am solving the questions, right? Select the option with correct property. Now you have to select the question with correct property. Let us see that. Now they have given us two things, NiCO4, NiCl4 2 negative. Best way is to firstly solve this, right? So NiCO4, guys, this is a very, very frequently asked questions. NiCO4, then you have NiCl4 2 negative, right? Okay. Now guys, very simple. This is X. This CO is a neutral ligand. So it is plus 0 equals to 0. So X is equals to 0, right? That means nickel in 28 atomic number, it is going to have argon 18 4s2 3d8. That is going to be the final electronic configuration. Here it is X minus 4 is equals to minus 2. X is going to be plus 2 here. And from here, what you are going to do? Nickel 28, and this is 4s2 3d8. After taking 2 electrons from here, what you will have? 2 electrons are taken out firstly from 4s only. So it will be 4s0, 3d8, right? So here, very important thing, CO. And this is Cl. This is a strong field ligand. This is a weak field ligand, right? Now this is D. This is your D. The mistake that students do, they just assume, ma'am, 8 electrons here, ma'am. Okay, no problem, ma'am. 1, 2, 3, 4, 5, 6, 7, 8. Ma'am, 1 D is left here. Array. Wrong. Then you will say, ma'am, DsP2 is the correct answer. No. You also have this thing here, 4s2. So total it is having 10 electrons, not 8. So you need to pair up 10 electrons here, right? You need to pair up 10 electrons here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now you have sp3 hybridization, which is correct. It is tetrahedral. What about this? 8 electrons. No pairing. 1, 2, 3, 4, 5, 6, 7, 8. Right? This is also sp3 hybridized. Now let us see the answers. They are not asking about hybridization. So guys, but you should know that both of them are sp3 hybridized. Okay, both of them are tetrahedral. But what about paramagnetic character? Here it is fully paired. It is diamagnetic. No unpaired electron. It is having unpaired electron. It is paramagnetic. So this will be paramagnetic. This will be paramagnetic and this will be diamagnetic. So D is going to be the correct answer. D for dosa ma'am is the correct answer. Okay. Got it? You can watch this because JEE questions can be asked directly in your NEET, right? Okay, so that has high chances. Then so you don't even need to see previous year topics. You just have to copy paste question can be asked, right? Okay, so now next is, which of the following complexes will exhibit least paramagnetic behavior? Least paramagnetic behavior. Least paramagnetic behavior. That means less number of unpaired electrons, right? Okay, so you have to go through them one by one. If you talk about this, this is chromium 2 positive. This is chromium 2 positive. This is Fe2 positive. This is CO2 positive. This is Mn2 positive, right? You have to write the electronic configuration here. H2 means all of them are in like weak magnetic, weak field only. So that is why no pairing it will have. Chromium is having 24 atomic number, 26 atomic number, 27 atomic number, 25 atomic number, right? Okay, yes. Now, chromium is electronic configuration is 4s1, 3d, 5. 2 electrons you will take, it will become 4s0, 3d, 4. Okay, now after this guys, Fe, it is 26, so it will be 4s2, 3d, 6. 2 electrons you take, it will become 3d, 6. Here cobalt is 4s2, 3d, 7. 2 electrons you take, it will become 3d, 7. Mn is 4s2, 3d, 5. So 2 electrons you take, it will become 3d, 5. Maximum number of unpaired electron. It is, if you draw it, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Whereas you already know, but still. Okay. Chalo. Now fill the electrons. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. So maximum are here. 5 unpaired electron. So answer will be D is the correct answer. Okay. D is the correct answer. Okay, ma'am, magnetic moment is less for C. No. C, wait a minute. Which of the following will exhibit? Acha, least paramagnetic. So sorry. I thought they are asking you the maximum paramagnetic. I thought they are asking you the maximum. I forgot to see that they are asking you the minimum. Okay. So here it is having 4, 4, it is 5. Least is for this one, that is 3 unpaired electron. It will be 3.8 something. So least is going to be for C. Right? Least is going to be for C. Right? Okay. Oh, kya baat hai. Very nice. Okay. So least is going to be from C. Next is match the list 1 with 2. List 1 with 2. Okay. So guys, simple. Let's see this. This is nickel CN4. Basically, I'll just write it here. Nickel CN4. This is 2 negative, right? This is 0. This is basically this is cobalt NH3 6 and this is 3 positive. We have solved these questions, isn't it? Haven't we solved all these questions? Do you agree with me or not? We have solved these questions, okay? 3 negative. 3 negative. We have solved these questions. We have solved for NiCN4 2 negative already. NiCN4 2 negative, we have solved this. NiCN4 2 negative. Have we solved for NiCN4 2 negative? No, we have not solved for NiCN4 2 negative. But we have solved for this. Cobalt NH363 positive, it is D2sp3. Right? And for cobalt 4, it is sp3d2. For fluorine, it is sp3d2. Okay, so I'll just write it here. Because we have already solved these two. This is D2sp3. This is sp3d2. Right? For NiCO4 also we have solved it here. We have solved it here. NiCO4, it is sp3 hybridization. NiCO4, it is sp3 hybridization. It is sp3 hybridization. Acha, we have not solved for NiCN4 2 negative, right? But I'll just firstly tell you the answer here, right? So this is अच्छा first तो we'll solve it. वैसे it will turn out to be DSP2, right? Not DSP3, it will turn out to be DSP2. It should be DSP2. Okay, I'll tell you how it will turn out to be DSP2. Wait a minute. So firstly, A is third, B is 1, yes. C is 4, C is D2sp3, that is 4. Yes, D is 2. Yes, so A will be the correct answer, right? Okay. Now, so if you have like practiced that enough, then so you can answer that in seconds, right? But those students who have not practiced it enough, how to solve it? NiCN4 twice. NiCN4 2 negative. What we will do? Firstly, solve the oxidation state. It will be x minus 4 equals to minus 2. X is going to be plus 2. Now, nickel 28 is going to be argon 18, 4s2, 3d8, right? Nickel 2 positive is going to be 2 positive. Take out 2 electrons here, 4s0, 3d8 simply. Now, this is going to be your D. This is going to be D. Cn is a strong ligand, so pairing will happen 1, 2, 3, 4, 5, 6, 7, 8. So you will be left with this D, this S here and this P here. So answer will be DSP2. Answer will be DSP2 is going to be the correct answer. That means square planar geometry. Right? Okay. So this is DSP2. Got it? Yes, everybody? Yes. CO, very good. CONH3 positive, cobalt NH3 positive. Here NH3 act as strong field ligand. Yes. NH3 sometimes it is acting as strong field, sometimes it is acting as weak field. But here it is acting as strong field ligand. Okay. Here it is acting as strong field ligand. Okay, guys. Yes, everybody. If you talk about now, one student have, put this question. So I'll give you one example. Just write it somewhere. Okay. For example, you have Cr. Wait a minute. The compound is Cr NH3 6,3 positive. Here this is acting as weak field. Here it will not cause any pairing. No pairing. But in this case, it will cause pairing. It will cause pairing. Right? That's why they are asking you this again and again. If they ask you chromium, there will be no pairing in this case. Okay? So just write it down. Write it down. In this case, it will not cause any pairing. So basically, it was not like when they were solving VBT, they already knew that what is strong field and weak field. Strong field, weak field is a concept of crystal field theory. We are just applying this here. Actually, what happened that time was that when they were experimenting by the magnetic movement. Now, in the question, they are asking us the magnetic movement. But in reality, in experiment, they knew what is the magnetic moment. They knew which is paramagnetic, which is diamagnetic by the experiment only. Then, for example, some compound is diamagnetic. Then they knew that it has to, pairing has to, we have to do pairing here. If a compound is paramagnetic, then there will be no pairing. So, in that way, most of the compounds were divided as strong field and weak field. But like NH3, sometimes it was causing pairing, sometimes it was not causing pairing. Right? Okay. Okay. Yes. Yes, everybody. How many questions? Huh? Last question only we have. Just saying how many questions we have for VBT. Acha. Now, here it is. Match the list 1 with 2. You have to match these two lists. Don't spam, guys. Don't spam in the comment section. Huh? Please don't spam, okay? Please don't spam. And yes, I'm waiting. I want to complete today. So let's complete 200 plus likes, okay? Right? Because you know that how much hard work I'm doing for you, right? So match list 1 with match list 2. So list 1 is this, list 2 is this. They're asking you the dipole moment. Here you can see that 4 unpaired electron. Here it will be 3 unpaired electron. Here it will be 0 unpaired electron. It will be 2 unpaired electron. First is that thing you need to know. Second is, see, I told you this compound. I just wrote that compound in the last slide. Okay, I just wrote it here, right? Chromium NH3 6 3 positive. It will not cause any pairing. That is why this is important. This will cause pairing. So write it down somewhere in your notes, right? So see, both the question they have asked. Cobalt, it is causing pairing. Here it will not cause pairing. So let us see that. Let us see that where it is. Let us solve it here only, right? So firstly, so we have Cr NH3 6 3 positive. Now we have chromium here. Chromium is 24. Here oxidation state is +3. Chromium is 24. So it will be 4s2, 4s1, 3d5. Right? So when you take out 3 electrons from here, it will be 4s0, 3d3. Okay. Now here I am saying no pairing it is going to cause. No pairing it is going to cause. 1, 2, 3, 4, 5. No pairing it will cause. So it will be 1, 2, 3. In cobalt it was causing pairing. Got it? In cobalt it was causing query. But here it is not causing any query. Why I am seeing your chats here. In cobalt it was causing pairing. But in chromium, it is not causing any pairing. The ligand is same. Okay. So this you need to remember. So that's why here it will have 3 unpaired electrons. So A is going to be 3 unpaired electron. That means A is 2. A is 2. So here it is going to be either this or this. These will be eliminated. Now for B, you have NiCl4 2 negative. For NiCl2 negative, we have already done this. Here you had 2 unpaired electron. NiCl2 negative, you had 2 unpaired electron. So the answer was 2. So it is 2 here. That means B is 4. B is 4. B is 4 here. So this is also eliminated. B is the correct answer. Now again, let us see for C. C, that is cobalt F6 3 negative. This also we have done, isn't it? We have done this also. Cobalt, where it was? We have done this. Cobalt F6 3 negative, it is having 4 unpaired electron. Can you see? It is having 4 unpaired electron. So here the answer, see, same thing they are repeating. Same compounds are getting repeated again and again. Right? So here it is 4 unpaired electron. That means it is first. So C is first, right? What about D? NiCN4 2 negative. This so we have just done here, right? It is having 0 unpaired electron. So here answer will be 0. Here answer will be 0. That means D is third. Answer we have already solved, right? By these two only, by elimination only, we have solved the answer. But it's just that I am telling you that like overall concept here. right? So here B is the correct answer. That means this will be the correct answer here. Got it? Yes, everybody. Now, do you have confidence on VBT? Just two topics we are left with, CFT and isomerism, okay? Just two topics and we'll be done with this lecture, right? Okay, yes, thank you, Sachin. Yes, guys, like this session. The tip is solve as much as possible, as many previous year questions as possible. Okay, yes. Understood everything you taught today, ma'am. Thank you, beta. Thank you. So now let us jump to the next topic, that is crystal field theory. Okay. Let us see the next topic, that is crystal field theory. I'm also in the end, I'll also give you one trick for isomerism. Usually students get confused in isomerism. So I'll give you simple trick on isomerism. Just learn that and that's it. Okay. Because isomerism, I would say VBT and CFT are like, if I would say that is if I would say that is 2x time important, then that will be x time important in simple maths. Okay, so here crystal field theory. Every single day and grind really hard and practice tough questions. Very good, Artha. Atharv. Okay, now let us see this crystal field theory. Now guys, in crystal field theory, basically I'll tell you in simple, right? Okay, so mark two things here. So basically we are going to talk about two things in crystal field theory, right? Those two things are going to be octahedral and tetrahedral complexes. Crystal field theory for square planar complexes is not in our syllabus, okay? So, for octahedral and tetrahedral you have in your syllabus. So, what you need to remember is, so basically crystal field is taking everything, it is taking that ligand and metals are having ionic interactions, they are having electrostatic interactions, and because of that this theory was given that basically why some ligands are causing pairing, why some are not causing pairing, is that you have 5 d orbitals, that is dx square minus y square, dz square, then you have dxy, dyz and dzx, right? So this is in E category and this is in T2 category. This is in T2 category, right? This is in E category and this is in, it's a very concluded manner I am telling you, okay? So this is an E category, this is an T2 category. Reason why this happened was because octahedral complexes, if you see here, they are basically along that axis, okay? The ligands are along the axis. This is x-axis, this is y-axis, this is x-axis, this is z-axis. Everything is along the axis. The ligands are along the axis, or you can say the ligands are along the axis. And in dx square minus y square and z square also, these are along the axis, isn't it? Isn't it? Right, na everybody? This is also along the axis, right? So now what will happen? Because these two orbitals, the lobes, the electron density is along the axis. It's like this. It's like this. For z square, it is like this. The electron density over here. So that means this is also along the axis. These are also along the axis. So the energy of E will increase here. That is why the diagram that you will have here is this. It's a simple thing. 1, 2 and this is 3. Basically, we draw the full diagram. I am telling you the concluded version, what you will use in the exam, right? You are not going to draw the full diagram in the exam. Firstly, you had 5 ligands, then they all will get excited, right? Then they will split. In octahedral, they split like this, 2 and 3, but in tetrahedral, they will split in a different manner. That is opposite. Opposite, why? Because in tetrahedral geometry, this is the tetrahedral geometry. In tetrahedral geometry, ligands are not along the axis. This is not along the axis. This is no axis. This is in between. If this is your x-axis, this is y-axis, this is in between the axis, right? So that is the reason we say that this is not along the axis. That is why the orbitals where electron density is between the axis, they will get high in energy. High in energy means less stability, right? If you also want to get that seat, your friend also want to get that seat, you will feel jealous. Similarly, they are feeling jealous of each other, right? So here, three orbitals above and 2 below, right? Okay. Now, octahedral, as you can see, it is having a proper symmetrical shape, right? That is why here we see EG and T2G. This is T2G. But here it is simple G for gerade. Gerade means symmetry. This is simply T2 and this is E. Right? Now, it is said that whenever you are filling the electron, for example, I want to fill the electrons firstly here, right? So, I will firstly fill these 3 electrons, 1, 2, 3. Then I will go to 4, 5, 6. Then I will jump to 7, 8. Right? Okay, got it? Now, important thing, right? So, your delta T, this is called delta O, crystal field splitting of octahedral. This is called delta T, right? So, delta T is equals to half of, almost half of, or you can say 4/9 of delta O. That means this delta T is half of delta O, right? That means delta O is very large, right? So here you can see that if this is like this is the difference, this is the difference, then it will be very less. This is going to be less, right? This is going to be less, right? It's like here you and your friend are living, you are living in ground floor and your friend is living in 14th floor. Here you are living on first floor, your friend is living on third floor, right? So it is T2. Now guys, this gap is called the splitting. If there is some strong field ligand, that will cause high splitting, right? If there is weak field ligand, that will cause less splitting, right? So always your tetrahedral, right, is yes. Tetrahedral is less. That is why very important thing now I am going to say here, right? Very important thing I am writing here, that tetrahedral will always form. Basically, what is high spin and low spin? High spin, low spin complexes mean that pairing will always happen here, right? So when you are filling, when the gap is very less, how the electrons will be filled? 1, 2, 3, 4, 5, then 6, 7, then 8. Basically, they will form low spin complex, high spin complexes, right? So tetrahedral will try to form high spin complexes. They will try to form high spin complexes always because the gap is very less. So if one electron I have filled here, second I am filling here, then the third electron will not be filled here. Rather, it will be filled here because the gap is very less, right? So that is why I am saying that high spin complexes, because spin is going to be high here. So high spin complexes are formed here. In octahedral, both low spin or high spin can be formed. Both low spin or high spin can be formed. It depends on the ligand, right? Here it will depend on the ligand. It will depend on the ligand, right? Whether it is forming high spin or low spin complexes. Now, very important thing that you have, one is, two things I am writing here. If your CFSC gap is very high, here CFSC gap is very low. Gap is very high. So here what will happen? Here gap is very high. It is caused by strong field ligand. Strong field ligand. Now when the gap is very high, it's like this. It will try to pair up the electron. That means low spin complexes will be formed. Low spin complexes will be formed. Here it is opposite. Weak field ligand, weak field ligand. Gap is very less. That means there is weak field ligand. That means high spin complexes are formed. High spin complexes are formed. Okay, high spin complexes are formed here. Yes, okay. Now, let us do the questions here. Oof, I can see the Janta running. Ma'am, we can't do that much hard work. You only crack, ma'am, IIT. We will sit here, ma'am. We are the ma'am totally gone. Why? Because we don't want to do that much hard work. Huh? Ma'am can stand here for hours and hours, but you can't. You can't sit. Acha, the match the list one with this. So you have chromium, all of them are weak field only, right? So you have all of them are octahedral only. And what we are going to do here, so it will be octahedral, you have this thing. This is how you fill octahedral. If you talk about chromium 3 positive, then you have Fe3 positive, then you have nickel 2 positive, then you have vanadium 3 positive. Chromium is basically 24, this is 26, this is 28, and this is 23, right? Okay. Firstly, though, you need to know the atomic number. Then what is the oxidation state here? 4s2 3d4. What is the electronic? Firstly, I am just writing the simple electronic configuration. It is 4s, it should be 4s1 3d5. It is 4s2 3d6. It is 4s2 3d8. It is 4s2 3d3. Right, now let's take 2 electrons from here. So it will be 3 electrons, sorry, 1, 2, 3. So it had 5 minus 2 is 3, right? 3 electrons from here each. So it will be, this will be 5, 7, 2, right? It is 5, 7 and 2. Well, 3 electrons I have taken out here, right? Now, just simply you have water, so water is not a very strong field ligand, right? So the pairing will not be that much, right? So that's why what will happen here? What will happen here? Wait a minute. So it will be like this. It will be like this, right? It's not a very strong field ligand, so that there will not be that much gap here. So it will be 3d3. It will be T2G3. That means for A you have 2. For A you have 2. That means A you have 2 over here, right? Then for B you have, for B it is 3d5. It means like this, right? So it will be 5 electrons, no? So it will be, wait a minute. There is no option for that. That means they are taking gap. They are taking gap here. So let's take gap then, right? Let's take gap then. 1, 2, 3, 4, 5. Now they have filled for 3d5 as 1, 2, 3, 4, 5. That means it is T2G3E2, right? T2G3E2, right? So it is third, right? Then what about C? C is this one, that is 3d7. So it will be 1, 2, 3, 4, 5, 6, 7. So here it will be T5, right? T5 and E2, right? T5 and E2. Wait a minute. So here it will be fourth one, right? Then you have, this is 3d2. So it will be again only 2. So it will be only this thing here. Wait a minute. 1, 2. So it will be T2. So it will be 1. So answer will be D. So firstly, I got to know the answer from the first thing only. Learning, we should solve all. Yes. Yes, for learning, we should solve all. It's like we knew the answer before only, that okay, it is D is the correct answer, right? Okay. Huh. Weak field. But they are taking so here they are taking the gap, right? Okay, so this is how you will solve this. Wait a minute, for nickel, is this 2 positive here? I have taken this as 3, hai na? So it will be 3d8 here. It will be 3d8 here. Then it will be T2, 6 and E2, right? So basically it depends on the question, what kind of options they have given you. Right? Based on that you can see whether, because water is usually it is weak field only, but here they have taken that the gap is enough to fill the upper electrons first, right? So basically it is, you can say that it is a weak field ligand, because water is a weak field ligand. So what we have studied here is that in a weak field ligand, the gap is less. So when the gap is less, for example, you and your friend are living just 2 floors next to each other, right? So you're living on first floor and he is living on third floor, and your lift is not working. So you can easily just go by the stairs, right? But if your friend is living at 14th floor, you will not go by stairs, right? You will be like, okay, I'll just call over, I will just talk over phone only, right? So that is the thing. Now, because the gap is very less, so that is why the electrons can jump here and there, right? Okay, got it? Yes. Yes, the first one is enough, but solve all the questions here, right? Now, next is, we are not in the exam hall, okay? In the exam hall, so obviously we'll solve the first one only, then go to the next question. But here we are practicing. You never know that in the exam what question they can ask you out of this only. The correct sequence of ligands in the order of decreasing order, right? Decreasing field strength. So this is based on spectrochemical series. For that, first you need to see the spectrochemical series. This is your spectrochemical series. You need to learn this. Very, very important, because 2 times the question has been asked in last 2-3 years only, right? So here carbon, CO carbonyl ligand, then you have water, then you have F negative, then you have S2 negative. This is directly from this spectrochemical series, right? Okay, the next question is also same. Yeah, this is a different question. Same kind of question you will see, right? So if iron 3 positive complex, so he's saying that this is iron 3 positive complex. This is Fe NH3XCN. This is a general question, okay? This is not based on any theory. So it is existing as X3 positive. That means if I am taking this as X plus, this is 3. The oxidation number is 3. X plus, because it is a neutral ligand, it is a -1 ligand. So it is 0 plus minus Y. So it will be minus Y equals to 0. So Y I can take it as 3. Can I say Y is equals to 3? Right? Can I say Y is equals to 3 here? Right? Y is equals to 3. Now you have to solve X. Has no electron in EG orbital, then the value of X plus Y. Okay. Now they are saying that it has no electron in the EG orbital. From there, can you predict one thing? This is a question of CFSC only. Fe3 positive, what is the electronic configuration, guys? Fe3 positive means F4s2 3d6. 3 electrons you are taking here, it will be 3d5. It is saying there is no electron in the EG. That means this is your T2, this is EG, this is existing in octahedral field. Octahedral, that means coordination number is 6, right? 3d5 means it will exist like this, 1, 2, 3, 4, 5. That means the gap is really large, because these are strong ligands, right? That is why the EG is empty, right? So we know that this is octahedral. So can we say that X plus Y is equals to 6? From that we can say what is the value of Y? Y is 3. X plus 3 equals to 6. X will be equals to 3. So now they are asking the value of X plus Y only. So X plus Y will be 6. So answer is C is the correct answer. Okay, got it? Okay. just 20 minutes more, yaar. Got it? So answer is 6 is the correct answer. Next is the number of unpaired d electrons in COH2O63 positive. Unpaired electrons. This though we have done, yeah. This though we have done. We have done this, right? Unpaired electrons. This though we have done in VBT only, right? This is not a question of CFT. This is a question of VBT. We have done this question where first question that we solved was this one only, right? Not the second question that we solved was this one only, right? So it is, they're asking you the unpaired electron, 0 unpaired electron we had here, right? So answer will be, okay, where is the question? So 0 unpaired electron we had, okay? 0 unpaired electron, this we have solved before also. 5th or 6th time, I think this question is getting repeated, right? Okay, so it is 0. Next we have the correct order of ligand arranged. Again, it is from the spectrochemical series, right? From the spectrochemical series, guys, from spectrochemical series, right? Okay, so from spectrochemical series, fluorine, bromine. So I think the answer would be yes. Okay, so from the spectrochemical series, you can see this is Br, this is F, then you have H2O, then you have NH3, right? Okay, so this is how you can use this any mnemonic. You can learn any mnemonic. Why I am not telling you any mnemonic is because most of you have learned it, right? So there is no use of telling you any mnemonic, right? Okay, so now next is the number of complexes from following with no electrons in the T2 orbital is. You should have no electrons in the T2 orbital. Okay, T2 orbital. It is tetrahedral. In tetrahedral, you have T2 here and EG here. No electrons in the T2. Guys, that means there should be pairing already. Pairing should be done already. That means the gap should be really large. That means this gap should be large. Gap should be large. That means very strong field is required, right? Only then you will have no electrons in T2, right? So strong field you can see. Okay, then so we have to solve this, right? Because most of them are weak field only. Now we have to solve this. If you talk about TiCl4, right here X is existing as X is equals to plus 4, right? So it is having T22, right? So it is 4s2 3d2. So you take out 4 here, it will be 4s0 3d0, right? So there is no electron in T2, right? So that is definitely there is no electron first. What about MnO4 negative? MnO4 negative, X minus 8 minus 1, X is equals to plus 7. Manganese is 25, it is 4s2 3d5. Mn7 positive means all electrons are gone here, right? So again it is having no electron in T2, right? So this is also no electron. So 2 already we have. Next is FeO4 2 negative, right? So X minus 8 is equals to minus 2, X is equals to plus 6. Again, you have Fe that is having 4s2 3d6. Take out 6 electrons, you will have 3d2, right? Fe 6 positive will have 3d2, right? This is having 3d2. That means if you talk about this thing here, right? So it will have 2 electrons here. Again, each T2 will be again empty, right? T2 will be empty only here, right? So this is also T2 is empty. What about FeCl4 negative? This is X minus 4 is equals to minus 1, X is equals to plus 3. So iron is what? 4s2 3d6. Fe3 positive. What do you mean by Fe3 positive? Right? Where you have CO? Where you have CO? What entity where you have CO? Kindly let me know. Right? So this is Fe3 positive. So it will be 4s0 3d5. Right? So definitely it is going to have, it is weak field ligand. That means it is not going to be that much. So it will have electrons here as well. So it will not be empty. Right? So 3 to till now we have find out where T2 is empty. Now let us see the last one. Last one is COCl4. That means it is X minus 4 is equals to minus 2, X is equals to plus 2. Cobalt is having 27. So it is 4s2 3d7. Cobalt 2 positive is 3d7. So here again it is weak. So here again 1, 2, 3, 4, 5, 6, 7. Again it will not be empty. So answer will be 3. Right? C will be the correct answer, that these three are going to have T2 as empty. Right? Okay. COH2 6 question. Wait a minute. Let me see. So cobalt only I took, na? Wait a minute. Have we solved this before or not? Yeah, thoda sa taras you can have on me. Acha, it is water here. I'm so sorry. Yes, it is water. It is water. So let me solve it here. Right? So, okay, I'll solve this here as well. This is X is minus 0. It is going to be X is equals to plus 3. Right? So it is going to be cobalt plus 3. Cobalt is 4s2 3d7. After taking out 3 electrons, it will be 3d6. Right? It is a weak field ligand. So you will have there will be no pairing here. So it will be 1, 2, 3. Right? Wait a minute. The number of unpaired electrons in d orbital. 1, 2, 3, 4, 5, 6. Then so it will be 4. The number of unpaired electron, then so it should be 4. COH2O. Then so it should be 4, guys. Water is acting as a weak field ligand, no? एक minute. You have oxalato. Wait a minute. Let me just see the spectrochemical series. Just give me a minute. Let me just see the spectrochemical series. Oxalato and water. है ना? हाँ. Cobalt, they are forming the. हाँ. ठीक है. So sorry. Yes. So oxalato and water with cobalt, they will show the pairing, है ना? So it will be where it is. I think my brain has stopped working now. So it is 0 here, है ना? It is 0 here. Yes. So with cobalt, it is going to show the pairing. So it will be, wait a minute, let me just solve this again. So it will be, yes, 1, 2, 3, 4, 5. Now it is going to show pairing 1, 2, 3, 4, 5, 6. Yes. So the same will be the answer. Yes, in hurry, I think I did the wrong thing. Right? So, but answer I predicted the right one only. Right? Yes. So now, next is this also we have done. This also we have done. 3 is the correct answer here. Right? Okay. Chalo. Now, next is match the list 1 with list 2. You have to match these two lists here. Again, this is T2, E2 only. List 1 is, and this is list 2. This is the same question, isn't it? This is the same question, right? This is the same question. This तो we have seen, we have done, the same question it is, right? Isn't it? So we have already solved this, right? Okay, we have already solved this question. So Ti, I think it was coming out to be, all of them were 0, 0, 0, है ना? So it was 0, 0, 0 only. Some typing mistake also, I feel. Some typing mistake is also present here. है ना? I forgot, yeah, what we wrote. I to erased everything there. So I think TiCl4 was having 0, 0. So it must be having third, right? And then you can eliminate these two options here. B is having 4 or 1. B was 4 or 1. We just did this question. B was having 4 or 1. 4 is E2, T2, 3. B was having D5, है ना? X was coming out to be 8 minus 2. It was coming out to be 6. Now after that, from iron you have taken out 6, right? That is 4s2, 3d6. You have taken out 6 means that will be 3d2. So it was 2. So answer was A. B is for 1. B is for 1, है ना? So answer will be C. Acha, for C you had x minus 4 is equals to minus 1, so it was 3, है ना? Yes, so it was 3, right? So answer, I think it should be C. Why it is D? Arey yaar, let me know what we solved, yaar. I just forgot. I have not written it there. Let me solve that again. I don't want to do that, but you are forcing me to do that. X minus, acha, X was coming out to be plus 4, right? So this was 22, right? It was 4s2, 3d2. I think they have given the wrong options, isn't it? Isn't it? They have given the wrong options because I'm not able to understand where they have written 4 and where it is written 2, right? So I will just eliminate this question because I'm not able to understand what they have written. If they are saying that A is 1, in that case, A is what? A is your E, G is also E0, and then T is also 0 here, right? So I can feel 0 here and here only, right? I thought this is 0, so it should be 0 over here. So it's very confusing because it is E2, E4, E0, E2. So I'm very confused at what they are written here. This is 0 here, this is 4 here, this is 2 here. Then for A, that should not be the correct answer, hai na? Basically, it's like this. For TiCl4, answer should be E0, T0. But here they have given the answer as, here they have given the, wait a minute, let me just take this thing here, right? So here basically, if you talk about TiCl4, answer should be this thing, that is third. So for that, this should not be the correct answer, right? So either they have given the option as wrong or maybe this statement is wrong. Got it? Okay? Hai na? Got it? So D is definitely not the correct answer if I write it like this. If I am writing it like this, this is E2, this is E4, this is E0. If I am writing it like this is E2, this is E4, and this is E0. If I am writing it like this, then your answer D will not be the correct answer, okay? So I'm just, it's the same question that we did here, right? So D will not be the correct answer. I'm just going to erase this, okay? So D will not be the correct answer, right? Rather, C will be your correct answer. C will be the correct answer, okay? Okay, got it? Chalo. Now, next is, okay, so following complexes they have given us, right? They have given us the following complexes. They are asking you the wave number here. So, very simple thing. So, we know that energy is equals to h mu, right? Or you can say hc by lambda. This is hc 1 by lambda. What is 1 by lambda? That is wave number only. So, basically it is hc wave number. This is energy. That means energy is directly proportional to wave number, right? More is the energy, more is the crystal field splitting energy, more will be the wave number. So you just have to write down the order of the strong field ligands, okay? So if you see this here, you have CN6, right? Then you have Cl here. Cl is a weak ligand, so A will be minimum, right? Then you have Cn here. Then you have H2O here. D can be the maximum, right? A will be the minimum, D will be the maximum. So I think C will be the correct answer. D will be the minimum. How come D is the minimum? The correct option for A, B, C, D in terms of wave number. More is the energy, more is the wave number, right? So energy is more in the strong field ligand. Which is a strong field ligand? Which is a strong field ligand? You have water here. Wait a minute. D, then you have A, D. D is a weak field, right, as compared to this. D, then you have A, right, then you have C, then you have B. Okay. So as basically here you have mixed ligands. That is why this confusion was there. So here you have only one Cl, right? You have 5 NH3. Here you have 6 Cn negative, right? And here you have 5 NH3 again here also. And here you have 4 water, right? So if you talk about the energy, firstly, so this is your tetrahedral, right? This is tetrahedral. These are octahedral. So energy of tetrahedral is always going to be less as compared to octahedral, right? So this is tetrahedral. That is why it will have the minimum energy. That means D is going to be the least value because this is going to be delta T. These are all your delta O. That is octahedral species. Now in octahedral, what you're going to do, you're going to see the ligands here, right? So if you talk about, if you see the ligands here, these two are having, you have to like very clear on this thought, okay? So this is NH3,5, this is NH3,5. The difference is this Cl and this water. Now when you talk about this difference, Cl is a weak ligand. That means here the energy will be low as compared to C. So A is having less energy as compared to C. Got it? Now this so we have predicted. What about this B? B is having CN6, which is a weaker ligand as compared to NH3. That is why D will be the minimum. So this is the order. Okay? Yeah, my brain is not braining right now. My brain is dead right now. Right? Okay, so I'll just solve the last part here. Right? And then I think my brain is telling me to sleep. Chalo. Now, firstly, let's do the last part here. So, guys, basically isomerism, they usually ask you questions based on geometrical and optical isomerism. So basically you have two kind of isomerism, geometrical and optical isomerism, right? In optical isomerism, no? So what you need to see is that in optical isomerism, you will have plane of symmetry concept here, right? So just remember this AC. AC means asymmetrical, will be optically active, which will be chiral. Okay, just remember this. You don't need to have plane. If there is no plane of symmetry, there is no center of symmetry, then that is called optically active. That will have an optical isomer. And in geometrical, you will have cis and trans. You will have cis and trans. That will be the answer. Okay, now let us see the questions. What kind of questions they can ask you. From that, you can tell the answer. Right? There is also one more topic, guys. Metal carbonyls. That is a very small topic. Okay. So firstly, let us see this. Number of complexes which show optical isomerism among the following is. Now, optical isomerism means no plane of symmetry you need to find out. Right? Okay, no plane of symmetry should be present here. So I'll just give you some general concepts where plane of symmetry is not found, right? So I'll give you general concepts regarding that. Just give me a second. Just give me a second. I'm just writing it here, where optical isomers are not found. Okay, where optical isomers are found. Now first is optical isomerism in tetrahedral. In square planar you will not see. Square planar will always have symmetry, okay? Square planar will always have symmetry. If you talk about a square planar complex, right? Okay, it will always have the symmetry. I know guys, please let me focus. Square planar will always have the symmetry. That is why there is never, we can say that there is not going to be any not plane will not be present. Always there going to be plane will be present. That is why no optical isomerism for square planar. For tetrahedral, I am just writing down which will show the, just directly just learn this and copy paste this in exam, right? Okay, so here you have three things. Either you can have MABCD type molecule, it will show optical isomerism. Then you have MAB2. AB2 means, do you know what is AB2 kind of molecule? AB is a ligand. It basically when you have unsymmetrical bidentate ligand, right? That kind of ligand. Then you have MAABB, that will not show. If you talk about any, they have MAABB ligand, that will not show. That will not show. Right? This will show optical isomerism. This will show optical isomerism. Why I am writing it directly? Because in the exam, you will not be able to make the models, right? So you have to know the direct thing, that which is showing, which is not showing, right? So in the exam, you will not have that much time. So what about octahedral? Octahedral, what will show? Usually they will ask you from octahedral only. So I'll write it for octahedral species only, right? Octahedral, firstly, optical isomerism will be shown by, wait a minute. Wait a minute. Optical isomerism will be shown by MA2, B2, C2. Then optical isomerism will be shown by, wait a minute, MAA3, right? Then optical isomerism will be shown by, very, very important, right? MAA. AA means symmetrical bidentate, like ethylene diamine, right? Like that. B2, it will show optical isomerism only in trans, right? Okay, so only in trans it will show optical isomerism. Then AA, B2, C2. I think that's enough. Now let us see this question, okay? Now let us see this question. Now here they are giving you 4 tetrahedral. Usually to not tetrahedral, they have given you octahedral only. This is a complex of MAA2B2, right? MAA2B2. MAA2B2, it will show optical isomerism in trans, right? Okay. MAA3, it will also show optical isomerism. This will to show optical isomerism, right? If you talk about AA2B2, that will show optical isomerism, AA2B2. This is also AA2B2 in trans, okay? So here the answer will be 3. Answer will be 3. 3 are showing the optical isomerism here. Okay, just from this I predicted this. Just from this I predicted. Okay. Okay. Okay, guys. Okay. So you just need to remember this, that it will show you optical isomerism in trans and this will show you optical isomerism everywhere. So from that only you can get your answer. Okay, got it? So you will have, wait a minute, Y4 either to I'll have to make the structures here because I then to I have to make the structures. Then just give me a minute, okay? Just give me a minute. Let me make the structures here. Only then I'll be able to tell you that what exactly. Basically, this is the bidentate ligand, okay? This is the bidentate ligand, okay? So just give me a second. Let me see because I'm getting confused in this AA2. This is your AA and how you're going to attach it here in octahedral geometry. Just give me a second, how many isomer complete they can form. Just give me a second, bacha. Just give me a second. Let me form a cis and trans isomer and let's see whether it is making any, whether it is showing any kind of cis or trans or not. Okay, then I'll have to see this with the help of this diagram only, right? Just give me a second. You'll see that how, why I am asking you to just learn this, okay? Because this you can only understand with the help of the diagrams, okay? So, if you talk about a cis, right? If you talk about cis is basically like this, okay? Because this will form a cis and trans. Cis will be like this. Cis will be like this. This is AA. This is your AA and this is BB. Okay. So I am making cis here. So for cis, these two will be opposite, right? So these two will be opposite. It will be like this. Oof. She is saying that I am going to die on my bed only. Beta, I am not even getting the bed. Hana, just think about me. And here I am just doing the structures here to get the correct answer. Okay, because I want to have that, because you should know from this method only. But in the exam, thodi you will get these structures, right? So this is basically your cis. Cis is having POS, right? Cis, you have the plane of symmetry. Right, as you can see, in cis you have the plane of symmetry, so there will be no optical isomerism, right? In cis you have the plane of symmetry, right? So here you have the plane of symmetry. Acha, this is AB kind, na? Wait a minute. This is AB kind. This is AA kind, right? This is AA kind. So it will show, this is AA kind, this is AA kind, right? So here it will not show, right? Cis, so you got to know na why it is not showing, why I told you that cis, if you have AA kind of ligand, right, like this, it will not show you the optical isomerism because we have the plane of symmetry here. We have so many plane of symmetry. If you want to see for trans, what you will have? Trans will be next to each other. So it will be next to each other. It will not have any plane of symmetry. Can you see? If I cut it from this side, it is not having any plane of symmetry. If I cut it from this side, it is not having any plane of symmetry. Here also no plane of symmetry. Here also no plane of symmetry. So trans is not having any plane of symmetry, right? So that's why we can write it here that trans is having no POS. No POS. No POS. So it is going to show the optical isomerism. But cis, here cis is having POS. So it will be no optical isomerism in this case, right? Okay. And one more that you need to write here is MAB twice and C2. Now, if you have MAB twice, okay, MAB twice, oxalato we were talking about, right? So AB twice is something like this. Wait a second, let me show you only how it will work, I wish I get very rich and I have money to buy 2-3 more atoms like this, so that I don't have to, do this on YouTube, right? I'm just picking out the atoms and then attaching the atoms, right? Oof. So wait a second. So it's like this. This is your AB2, right? If I'll draw the cis structure of this, see, in this question, what they have given you is 2-3 kind of things, right? So first is they have given you this thing. First is this thing, they have given MAA thrice, right? This will to show optical isomerism. So this will show optical isomerism. Trans will always show optical isomerism because there is no plane of symmetry here. What about cis? If you have cis, this is cis MAA2 B2. This will also show, this will not show optical isomerism, this will not show. What about cis C chromium oxalato twice Cr2, right? So this is cis they are talking about. So let's make a cis structure of that. Let's make a cis structure of that. Cis structure means this kind of structure, right? So as you can see here, the cis structure is like this, okay? Cis structure is like this. This is the cis structure, right? So here you can see that if I divide it like this, then I can have the plane of symmetry here. I can easily have the plane of symmetry here as well, right? So it will also know the answer will be 3 only, right? So yeah. Okay, then to we have done it right only. Chalo, let's do the second question, because I to have solved you the, I to have given you the geometrical figures also, but then also there is plane of symmetry. That means 3 was the correct answer, right? Okay, okay, है ना? Can you find anything else? है ना? This is 6 coordination number. Here also plane of symmetry was here we can say not present. This is trans, so that's why they're asking the optical isomerism. So I think 3 should be the correct answer, right? Chalo. Now let us see this thing here. The metal atom present in complex MABXL, where ABXL are unidentate ligand and M is metal involved sp3 hybridization. The number of geometrical isomers exhibited by this. Now, here they are saying that this is tetrahedral. Now this is a very simple, because in tetrahedral it will not show any geometrical isomerism. Tetrahedral will not be able to form cis and trans. In tetrahedral you cannot see cis and trans species here, right? That is present in octahedral or square planar. So answer will be 0. Answer will be 0 is the correct answer. Chalo. Now next is the correct IUPAC naming. Correct IUPAC naming of this. Now, correct IUPAC naming, just 1-2 question they have asked from IUPAC naming. Let's go through that. Basically, when you have a complex ligand, then you use bis, tris, tetra, kes, these things. So here you will not use di, you will use bis, right? Okay, you will use bis. Now, what is the name? Bis bromo, that is not the correct thing. Dibromo it is. Dibromo, then you have bis. Trimethyl phosphine, platinum, and here it is 2. So answer will be C is the correct answer, okay? C is the correct answer. Then you have next one. An octahedral complex with formula COCl3 dot NH3 upon reaction with excess of AgNO3 solution gives 2 moles of AgCl. See, you have this compound COCl3 dot NH3. Guys, now here they are saying that you have 2 moles of AgCl. That means inside the bracket you have 2 Cl2, right? Now they are saying it is a octahedral complex, right? It is a octahedral complex. That means total 4 ligands it would have, right? Total 6 ligands it would have. That means NH3 are 4 inside it, right? So now it is consider oxidation number of cobalt in the complex is X, the value of X plus N. We know that coordination number X is equals to 6. What is N? N value, that means total number of NH3 that you will have is 4, right? Okay. Wait a minute. So total number of NH3 they are saying, right? So cobalt is having 2. It is octahedral complex. This is 4, right? So they are saying that consider the oxidation state. Acha, oxidation state. This is X minus 2 plus 0 is equals to, this will be Cl2, so it will be minus 2 here, right? Okay, so it will be minus 2. Wait a minute. Wait a minute. Complex with formula COCl2. Acha, we are left with one Cl here, right? We are left with one Cl here. So it will be Cl here. So it will be positive over here, right? So answer will be, it will be positive and this is negative, right? So it will be X minus 2 plus 0 is equals to plus 1. So X will be equals to plus 3, right? And what about the, if they are saying the oxidation number is X, N is the coordination number, right? How many NH3 you will have? NH3 you will have is 4. I think my brain has stopped working or what? An octahedral complex with formula COCl3 on dot NNH3 upon reaction with excess of AgNO3 is giving 2 moles of AgCl. That means 2 moles of Cl are inside it. 1 mole of Cl will be outside, right? Consider oxidation number of cobalt is X, right? So oxidation number of cobalt will be plus 3 here, right? Then N is the value of N. Two moles of outside, ma'am. Oof, oh God, I think my brain, I am getting little bit, I think I need some break now. I'll just drink some water because my energy has been like really down now. I know why I'm doing such silly mistakes. Oh my God, I can't expect this from myself. Okay, so let's see that question again. Octahedral complex with formula COCl3 upon reaction with excess of Ag in solution give 2 AgCl. Obviously, that will be outside. So 2 Cl will be outside, 1 Cl will be inside. It will be NH3, 5. Then it will be CO here. Now it is going to be plus 2 here. So it will be minus 2 over here. So it will be X plus 0 minus 1 is equals to plus 2. X is going to be plus 3, right? My brain has literally stopped working now. So X is equals to plus 3, but I'll complete today, right? So X is equals to plus 3. Then we have N value is 5. So 5 plus 3 is equals to 8. Yes. Okay. Yes. Guys, I don't know. My energy is really down today. Today, nahi. Now only. Just my legs are literally shivering right now. The F negative ions that enamel of the on teeth much hardened by converting hydroxyapatite, the enamel on the surface of the teeth, into much harder fluoroapatite having the formula. So this is also a very frequently asked question, right? So just need to know the formula here, right? Okay, fluoroapatite. Okay, fluoroapatite. Now what is going to be the correct answer? Yes. Thank you so much, champion. Thank you so much. I want to take break, but if I take break of 10 minutes now, what will happen? Your time will get waste, right? Then what will happen? I'll again join. Then at 1 p.m. so I will not have energy. To 1 a.m. so I am totally dead because I sleep by 11 p.m. That's why my brain is shutting down, right? So here the answer is going to be D, right? That is your formula. Right, now we are going to do, this is the number of ambident. Ambident is the one which is having 2 donating sites. So NO2 is having 2 donating sites, SCN is having 2 donating sites, and CN is having 2 donating sites. So it is 3 is the correct answer, right? Okay, now last 2-3 questions we have from metal carbonyls. Metal carbonyls are basically, this is carbonyl, right? What it is doing is, your metal carbonyl, right, it is showing, this is, for example, it is behaving as a ligand and this is your metal. So what will happen? Usually ligands donate metal, right? It will donate by sigma, and the ligands will also accept here with pi bonding, right? Okay, so that is called synergic or back bonding. So based on that and based on some of the structures, we have some questions here for you, right? 3-4 questions we have from here. First is, a pi bonding MO has lower electron density above and below in the internuclear axis. So if you talk about the pi bonding, basically the electron density is like this, okay? The electron density is like this. So it is not lower here, right? It is not lower here, it is maximum here, right? So the first is false, right? The first statement is definitely the false statement, right? Then pi star anti-bonding MO has a node between, that is true. How come it has a node? This is the node that you will see, right? When it is overlapping, it will form a node here. So pi star anti-bonding, that will form a node over here, right? So that is statement 1 is false and statement 2 is true. Then you have the next question, that is, the coordination geometry around the manganese is decacarbonyl dimanganese. So basically these are directly mentioned in your NCERT. 3-4 structures are given to in your NCERT or based on metal carbonyls. Directly from that the questions are asked, right? So basically, as you can see the structure of dimanganese metal carbonyl, so you have manganese bond also, and here one manganese is having octahedral structure, 1 2 3 4. That means it is having octahedral, this kind of structure only, one above one below and here and there, this kind of structure it is having, right? So this is your octahedral structure, right? Then next is, in which of the following metal carbonyls forms a bridge between metal atoms? Now, which will form a bridge between metal atoms? Now, right, this structure is given in your NCERT. This is also given. This is also given. This is not given in your NCERT. So, let me show you the structures here. If you talk about this structure here, this is cobalt and this is carbonyl. Right, it is forming a bridge. If you talk about this here, carbonyl is not forming a bridge here. If you talk about this here, carbonyl is not forming a bridge here. Here also the carbonyl is not forming the bridge here, right? So this is a very, very important question. And if you see in old NCERT, some other structure is given. In new NCERT, some other structure is given. So you have to follow new NCERT, not the old NCERT. So here the question answer is going to be A, which is going to form metal carbonyl is forming the bridge. So in cobalt, the metal carbonyl is forming the bridge here, right? Okay. Yes. Chalo. Now guys, that was all about today, but I have one query here, right? That was for that optical isomers. So we will see that why cis and trans, because I have also made the structures here, the cis structure also I have made, but still it is coming out to be opposite. So we'll see that what exactly, why it is coming out to be opposite. I'll go through that question again. I'll see that, I'll make the structures and I'll see that what we can do about it. And then I'll give you a very summarized version of that what are the isomers that are showing, what are the general octahedral species and tetrahedral species that are showing optical isomerism and what are not showing. And also I'll see the correct answer for that question. Okay. Yes. Yes, so that was one query that we are left with after this class, but we will solve that on Saturday, right? Okay, chalo, now I am very, very sleepy, very tired, right? It was supposed to be a short class, but no worries, right? But yes, to all the students who are watching this full lecture, watch the first part of this lecture as well, because the internet got disconnected. That's why the full lecture is not this one, but there is also one hour extra lecture that you will see in this series only, right? Okay, then bye bye, guys. See you all in the next session. Bye bye. Saturday 7 p.m. and that will be easy for you because I'll prepare the pre-written notes I'll take, and for that, from that notes only we are going to solve everything, right? Chalo. Thank you so much. Okay, bye bye. Take care. See you all in the next class. Bye bye.